here from Simplilearn. Welcome to this video on Microsoft Azure full course. In this full course, we will learn everything about Azure in detail with an introduction to what Microsoft Azure is. Then, we will look into its concepts in detail. Our experts will give you a quick training on Azure services. Moving forward, we will understand Azure Machine Learning, Azure Active Directory, and Azure Virtual Network. After that, we will be looking into few major differences between AWS and Azure. And then, we will have a quick understanding of how the famous cloud providers AWS, Azure, and GCP are different from each other. Finally, we will conclude this video by discussing the top 25 important Azure interview questions and answers for beginners and experience level candidates. By the end of this video, I can assure you that all your Azure related queries would have been answered. For this training with me, I have our experienced Azure expert, Sam, Rahul, and Alan Carl. Together, we will take you through the various topics of Azure. So, let's start with an exciting video on the Microsoft Azure cloud provider. Before we begin, make sure to subscribe to our YouTube channel and hit the bell icon. Never miss an update from Simplilearn.
Hi guys, this is Rahul from Simplilearn, and today we'll be talking about one of the fastest growing and second largest cloud computing platform in the market right now. I'm talking about Microsoft Azure. Now before we begin, let's talk about what we'll be covering in this video. First, we'll talk about why you should be interested in cloud computing, what exactly is cloud computing, what is Microsoft Azure, some of its services, and the users of Azure. Now, let's start with why you should be interested in cloud computing. Now, let's say you have an idea for a revolutionary application, an idea that ticks both the boxes when it comes to good applications. One, it has great user experience, and two, it'll be highly profitable. Now, for it to be successful, you'll have to release it on the internet. People need to use it, they need to spread the word, and then it'll become truly famous. However, for that, you're going to need servers, storage, developers, a dedicated network, and application security to ensure your application works the way it does. Now, these are a lot of components, and that's where the problem lies. There are two major disadvantages to this approach. The initial setup is very expensive and risky, which means this requires a huge amount of capital upfront to ensure that it works properly. And the downside is, if your application does not become famous or it doesn't return as much as you expect it to, you're probably not going to get the money back, which means it provides a huge amount of risk. And then, on the flip side, if it does become famous, your number of users have increased, which means that you'll have to buy more servers and storage systems to keep up with your demand. And this problem can be solved with the help of cloud computing. Now that you know why you should be interested in cloud computing, let's go into the details of what exactly is cloud computing. Now, cloud computing is basically a platform that gives you access to a number of computing resources. And this is possible with the help of the internet. Now, as a user, all you need to do is go to a cloud service provider through your laptop or your computer, through the internet, of course, connect to that cloud service provider, and then there you go. You have access to computing resources. Now, computing resources may include, serverless computing, virtual machines, storage, and so much more. Now, let's dig a little deeper. Now, basically, these cloud service providers actually have massive data centers. Now, in these data centers, what you have are hundreds of servers. Also included are storage systems and mainly several organizations' critical components. So these are very secure, safe locations where a large amount of data is stored, hence the name data centers. Now, it is to these data centers that users actually connect to collect their data or use it. So actually, users can access any service based on their requirement. Now, like I told you, there's a number of services the user can use. For example, now if you want a notification every time someone sends you a message, or perhaps once you get an email, you need a copy of it created. Now, for all of this, there are services. And most importantly, almost every cloud service provider has this option where users only pay for the service that they use. So there's no charge upfront where they tell you that you need to pay X amount of money so that you can use our services. You're only paying for the amount of time that you're using these services. Now, cloud computing is used for a wide variety of reasons. Firstly, there's machine learning and data analysis. Now, basically, there are services that analyze your data and tell you how you can work with this data better. Then there's data storage and backup, streaming media content. For example, did you know that the shows that you watch on Netflix, actually all of them are in the cloud? So you're connected to the internet and you browse through Netflix and you get access to the videos. These are possible with the help of cloud service providers. There's creating and testing applications, automating software delivery, which is a component in DevOps, and hosting blogs and applications. So now, what is Azure? What's the big cloud service provider all about? So Azure is a cloud computing platform provided by Microsoft. Now it's basically an online portal through which you can access and manage resources and services. Now, resources and services are nothing but, you can store your data and you can transform the data using services that Microsoft provides. Again, all you need is the internet and being able to connect to the Azure portal. Then you get access to all of their resources and their services. In case you want to know more about how it's different from its rival, which is AWS, I suggest you click on the top right corner and watch the AWS versus Azure video so that you can clearly tell how both these cloud service providers are different from each other. Now, here are some things that you need to know about Azure. It was launched in February 1st, 2010, which is significantly later than when AWS was launched. It's free to start and has a pay-per-use model, which means, like I said before, you need to pay for the services you use through Azure. And one of their most important selling points is that 80% of Fortune 500 companies use Azure services, which means that most of the bigger companies of the world actually recommend using Azure. And then Azure supports a wide variety of programming languages, the C#, Node.js, Java, and so much more. Another very important selling point of Azure is the amount of data centers it has across the world. Now, it's important for a cloud service provider to have many data centers around the world because it means that they can provide their services to a wider audience. Now, Azure has 42, which is more than any cloud service provider has at the moment. It expects to have 12 more in a period of time, which brings its total number of regions it covers to 54. Now, let's talk about Azure services. Now, Azure services have 18 categories and more than 200 services, so we clearly can't go through all of them. It has services that cover compute, AI and machine learning, integration, management tools, identity, DevOps, web, and so much more. You're going to have a hard time trying to find a domain that Azure doesn't cover. And if it doesn't cover it now, you can be certain they're working on it as we speak. So first, let's start with the compute services. First, virtual machine. With this service, what you're getting to do is to create a virtual machine of Linux or Windows operating system. It's easily configurable. You can add RAM, you can decrease RAM, you can add storage, remove it. All of it is possible in a matter of seconds. Now let's talk about the second service, cloud service. Now with this, you can create an application within the cloud, and all of the work after you deploy it, deploying the application that is taken care of by Azure, which includes, provisioning the application, load balancing, ensuring that the application is in good health, and all of the other things are handled by Azure. Next up, let's talk about Service Fabric. Now with Service Fabric, the process of developing a microservice is greatly simplified. So you might be wondering, what exactly is a microservice? Now a microservice is basically an application that consists of smaller applications coupled together. Next up, functions. Now with functions, you can create applications in any programming language that you want. Another very important part is that you don't have to worry about any hardware components. You don't have to worry what RAM you require or how much storage you require. All of that is taken care of by Azure. All you need is to provide the code to Azure and it'll execute it, and you don't have to worry about anything else. Now let's talk about some networking services. First up, we have Azure CDN, or the Content Delivery Network. Now the Azure CDN service is basically for delivering web content to users. Now this content is of high bandwidth and can be transferred or can be delivered to any person across the world. Now these are actually a network of servers that are placed in strategic positions across the world so that the customers can obtain this data as fast as possible. Next up, we have ExpressRoute. Now with this, you can actually connect your on-premise network onto the Microsoft cloud or any of the services that you want through a private connection. So the only communication that happens is between your on-premise network and the service that you want. Then you have virtual network. Now with virtual network, you can have any of the Azure services communicate with each other in a secure manner, in a private manner. Next, we have Azure DNS. So Azure DNS is a hosting service. which allows you to host their DNS or domain name system domains in Azure. So you can host your application using Azure DNS. Now for the storage services. First up, we have disk storage. With disk storage, you're given a cost-effective option of choosing HDD or solid-state drives to go along with your virtual machines based on your requirements. Then you have blob storage. Now, this is actually optimized to ensure that they can store massive amounts of unstructured data, which can include text data or even binary data. Next, you have file storage, which is a managed file storage and can be accessible via the SMB protocol or the server message block protocol. And finally, you have queue storage. Now with queue storage, you can provide durable message queuing for an extremely large workload. And the most important part is that this can be accessed from anywhere in the world. Now, let's talk about how Azure can be used. Firstly, for application development, it could be any application, mostly web applications. Then you can test the application, see how well it works. You can host the application on the internet. You can create virtual machines like I mentioned before. With the service, you can create these virtual machines of any size or RAM that you want. You can integrate and sync features. You can collect and store matrices. For example, how the data works, how the current data is, how you can improve upon it. All of that is possible with these services. And you have virtual hard drives, which is an extension of the virtual machines where these services are able to provide you a large amount of storage where data can be stored.
I'm Sam, an Azure Cloud Architect working for Simplilearn. And I'm more than glad to walk you through this session where we're going to talk about Azure in great length and breadth. And if you're looking for a video that talks and walks you through all the services in Azure, then this could be one of the best video you could find in the internet. And without any further delay, let's get started. Everybody likes stories, right? So let's get started with a story. In a city not so far away, a CEO had plans to expand his company globally and called one of his IT personnel for an IT opinion. And this guy has been in the company for a long time and is very seasoned with the company's infra. And he nicely answered the questions with what he foresaw. And he said, I have a good news and a bad news for us to go global. And he starts with the good news. He said, Sir, we're well on our way to become one of the world's largest shipping company. And the bad news is, however, our data centers have almost run out of space and setting up new ones around the world would be too expensive and very time consuming. Now the IT personnel, let's call him Mike, now he explains the situation from how he saw it. But the CEO had done some homework about how he was going to do it. And he answered Mike saying, don't worry about that, Mike. I've come up with a solution for a problem and it's called Microsoft Azure. Well, Mike is an hard-working and honest IT professional working for that company, but he did not spend time on learning the latest technologies. And he asked this question very honestly, how does it solve a problem? And the CEO begins to explain Azure to Mike, and he starts with what is cloud computing, and then he goes on and talks about Azure and the services offered by Azure and why Azure is better than the other cloud providers. And what are the great companies that uses Azure and how they got benefited out of it. And then he winds it all up with the use cases of Azure. So he begins his explanation saying Microsoft Azure is known as the cloud service provider and it works on the basis of cloud computing. Now Microsoft Azure is formerly known as Windows Azure and it's Microsoft's public cloud computing platform. It also provides a range of cloud services, including some of them are compute, analytics, storage, and networking. We can always pick and choose from these services to develop and scale our applications or even plan on running existing applications in the public cloud. Microsoft Azure is both a platform as a service and infrastructure as a service. Let's now fade their conversation out and let's talk about what is cloud computing, Azure, services offered by Azure, how is Azure leading when compared to other cloud service providers, and what are the companies that are using Azure. Let's talk about that. In simple terms, cloud computing is being able to access compute services like servers, storage, database, networking, software analytics, intelligence, and a lot more over the internet, which is the cloud, with the flexibility of the resources that we use. Like anytime I want a resource, I can use one and it becomes available immediately. And anytime if I want to retire a resource, I can simply retire a resource and not pay for it. And we also typically pay only for the services that we use, and this helps greatly with our operating cost to run our infrastructure more efficiently and scale our environment up or down depending on the business needs and changes. And all the servers and storages and databases and networking, all that are accessed through the network of remote systems or remote computers hosted in the internet, typically in the provider's data center, which is Azure in this case. Now, we don't use any physical server or an on-premises server here. Well, we still use physical servers and VMs, hosted on a hardware or a physical server, but they're all in the provider's environment and none of them sit on premises or in our data center. We only access them remotely. It looks and feels the same, except for the fact that they are in a remote location. We access them remotely, do all the work remotely, and when we're done, we can shut it down and not pay for them. So some of the use cases of cloud computing are creating applications and services. The other use cases are storing or using cloud for storage alone. If there is one thing that ever grows in our organization, is the storage. Every new day there is a new storage requirement, and it's very dynamic. It's very hard to predict, and if we go out and buy a big storage capacity upfront, until we use the storage capacity fully, the empty storages, we're wasting money on them. So instead, I can go for a storage which scales dynamically, that's in the cloud. Put storage or put data in the cloud and pay only for what you're storing. And for the next month, if you have deleted or flushed out some files or data, pay less for it. So it's a very dynamic storage in the cloud, and a lot of companies are getting benefited from storing data in the cloud because of its dynamic in nature and the cost that comes along with it, the cheap cost that comes along with it. And also they give a lot of the providers like Azure, they give data replication for free. They promise an SLA along with the data we store in the cloud. So there's an SLA attached to it. And they also provide data recoveries as well. If in case something goes wrong with the physical disk where our data is stored, Azure automatically makes our data available from the redundant or other places where it had stored our data because of the SLA they wanted to keep. The other use case for Azure is hosting websites and running blogs using the compute service. Be it storing music and letting your users stream the music, Azure is a good place to store music and stream the music with the benefit of CDN, Content Delivery Network, which allows us to stream video or audio files with great speed. With Azure, our audio or video application works seamlessly because they are provided to the client with very low latency, and that improves the customer experience for our application. Azure Compute Service is a good place for delivering software on demand. There are a lot of softwares, embedded softwares that we can buy using Azure, and everything on a pay-as-you-go service model. So anytime we need a software, we can go out and immediately buy the software for the next 1 hour or 2 hours, let's say, and use them and then return it back. We're not bound to any yearly licensing cost by that. Azure Computing Services has analytics available for us with which we can analyze, get a good visualization of what's going on in a network, be it logs, be it the performance, be it the metrics. Instead of looking at logs and searching logs and trying to do manual things over the heaps and heaps of logs that we have saved, Azure Analytics Services helps us to get a good visual of what's going on in the network. Where have we dropped? Where have we increased? Or what's causing? What's the major driver? What is the top 10 errors that we get in the server, in the application? Stuff like that. Those can be easily gathered from the Azure analytic services. Now, cloud is really a very cool term for the internet. A good analogy would be looking back anytime we look at a diagram. When we do not know how things are transferred, we simply draw a cloud, right? For example, a mail gets sent from a person in one country to a person in the other country. There are a lot of things happening in between from the time you hit the send button and the time the other person hits the read button, right? And the simple and the easiest way of putting it in a picture is simply draw a cloud, and on the one end, one person will be sending the email, and on the other end, the other person will be reading the email. So a cloud is a really cool term for the internet. Now that's some basics about cloud computing. Now that we've understood about cloud computing in general, let's talk about Microsoft Azure as a cloud service. Now, Microsoft Azure is a set of cloud services to build, manage, and deploy applications on a network with the help of Microsoft Azure's frameworks. Now, Microsoft Azure is a computing service created by Microsoft basically for building, testing, deploying, and managing applications and services through a global network of Microsoft managed data centers. Now, Microsoft Azure provides SaaS, which is software as a service, and PaaS, which is platform as a service, and IaaS, infrastructure as a service, and they support many different programming languages, tools, and framework. And those tools and framework include both Microsoft specific and third-party software. Now let me pick and talk about a specific service. For example, management. Azure Automation provides a way for us to automate the manual, long running and frequently repeated tasks that are commonly performed tasks both in cloud and enterprise environment. It saves us a lot of time and increases the reliability, and it kind of gives a good administrative control and even schedules the task automatically to be performed on a regular basis. To give you a quick history of Microsoft Azure, it was launched on 1st February 2010, and it was awarded, or it was called an industry leader for infrastructure and platform as a service by Gartner. Now, Gartner is the world's leading research and advisory company. This Microsoft Azure supports a number of programming languages like C#, Java, and Python. All these cool services we get to use and pay only for how much we use. For example, if we use for an hour, we only get to pay for an hour, even the costliest system available. And if we use them for an hour, we only pay for that particular hour, and then we're done. No more billing on the resource that we have used. Microsoft Azure has spread itself more than 50 regions around the world. So it's quite easy for us to pick a region and start provisioning and running our applications probably from day one, because the infrastructure and the tools and technologies needed to run our application are already available. All that we have to do is commit the code in that particular region or build an application and launch it in that particular region, and they become live starting day one. Now, because we have 50 regions around the world, we can very carefully design our environment to provide low latency services to our customers. All right, instead of in traditional data center, let's say, customers will have to, or their request will have to travel all the way around the globe to reach a data center which lives in the other side of the planet. And this adds more latency to it, and it is really not feasible to build a data center near each customer location because of the cost involved. But with Azure, it's possible. Azure already has data centers around the world, and all that we have to do is just pick a data center, build an environment there. They're available starting day one, number one, and also the cost is considerably saved because we are using a public cloud instead of an physical infrastructure to serve those customers from a very local location. And the services that Azure is offering is ever increasing. As of now, as we speak, we have like 200 plus services offered, and they span through different domain or different platform or different technologies available within the Azure console portal. Now we're going to talk about that later in this section, so hold your breath till we talk about it. But for now, just know that we have like 200 plus services offered by Azure. Let's now talk about different services in Azure, starting with artificial intelligence plus machine learning, where we have a lot of tools and technologies. So the wide variety of services available on Azure includes artificial intelligence plus machine learning plus analytic services to get to give us a good visual of how the data or how the application is performing, or the type of the category of data stored, and to read from the logs. And variety of compute services, different VMs with different size and different operating systems, different containers available, different type of databases available, a lot of developer tools that are available for us, and identity service to manage our users in the Azure cloud. And those users can be integrated or federated with, let's say, Google, Facebook, LinkedIn. So there are some external federation services. They can be used to integrate with our identity system. IoT services, IoT tools and technologies available, and management tools to manage the users. Creating identity is one, and then managing them on top of it is a totally different thing. And we have tools, technologies to manage the users. Cool services for data migration. Data migration is now made simple. Tools and technologies available for mobile application development. And I can plan my own network in the cloud with the networking services. I can implement my own security, both Azure provided and third-party security services on Azure cloud. That's now possible. And a lot of storage options available in the cloud. So these are just a glimpse of the big list of services available in Azure cloud. So that was a glimpse of what's available in the cloud. Let's talk about the services in a specific. Let's take compute for example. Whenever we're building a new application or deploying existing ones, the Azure Compute Service provides the infrastructure we need to run and maintain our application. We can easily tap in the capacity that Azure Cloud Service has, and we can scale our compute requirement on demand. We can also containerize our application. We have the option of choosing Windows or Linux VM machine and take the advantage of the flexible options Azure provides for us to migrate our VMs to Azure, and a lot more. And these compute services also include a full-fledged identity solution, meaning integration with Active Directory in the cloud or on-premises, and a lot more. Let's look at some of the services that this compute domain provides. Some of the services the compute domain provides are virtual machines. And this Azure Virtual Machines gives us the ability to develop and manage a virtual computer environment or a virtualized environment inside Azure's cloud environment, that too in a virtual private network. Now we will talk about virtual private network at a later point, but as of now, just know that there are a lot of services available in Azure Compute Service that we can get benefited from. We can always choose from a very wide range of compute options. For example, we have an option to choose the operating system. We have the option to choose whether the system should be in on-premises or in the cloud, or do we want to maintain the environment both in on-premises and in the cloud. We have the option of choosing the operating system, whether we want to use our own operating system with some software attached to it, or do we want to go and buy the operating system from the cloud, from Azure Marketplace. And these are just a few of the options available for us when we want to buy the compute environment. And these compute environments are easily scalable, meaning we can easily scale our VM instances from one instance to thousands of virtual machines in a matter of minutes, or simply put, in a couple of button clicks. And all these services are available on a pay for what we use model, meaning there is no upfront cost. We use the service and then pay for the services that we have used. There is no literal long-term commitment when it comes to using virtual machines in the cloud. And most of the services are built on a pay per minute billing basis. All right. And at no point, because of the pay per minute billing model, at no point we will be overpaying for any of the services. That's attractive, isn't it? Now let's talk about batch service. Now, batch service is always independent, regardless of whether you choose Windows or Linux. It's going to run fairly well. And with batch service, we can take advantage of the environment's unique features. And not only that, in short, the batch service helps us to manage the whole batch environment, and also it helps to schedule the jobs. Now, this Azure batch service actually runs on a large scale, parallel and high performance computing. Because of that, batch jobs are highly efficient in Azure. And when we run batch services, this Azure batch creates a pool of computer nodes and installs the needed applications that we want to run, and then it schedules jobs to those individual nodes in those pools. As a customer, there is no need for us to install a cluster, or there is no need for us to install a software that actually schedules the jobs, or even to manage or even to scale those infrastructure or the software, because everything is managed by Azure. And this batch service is a platform as a service. There is no additional charge for using this batch service, except for, the only charges that we'll be paying is for the virtual machines that the service uses, and the storage that we will be using, of course, and the networking services that we will be using for this batch service. Let's summarize. This batch service, we have a choice of operating system that we can pick and use, and it scales by itself. Now, the alternative for the batch would be queues, but in queues, we'll have to pre-provision and pay for the infrastructure even if we're not using it. But with a batch, we only pay for what we use. And this batch service helps us to manage the application, manage the scheduling as a whole, as if they are just one thing. As next thing in the compute domain, let's talk about this Fabric service. Now, this Fabric service is actually a distributed system platform that helps us to package, deploy, and manage a scalable and a very reliable microservice and containers. And what does it help? This Azure Fabric service helps us, or it helps the developers and administrators, so they can avoid the complex infrastructure problems, and they can focus only on implementing workloads or taking care of their development, taking care of their application, instead of spending time on infrastructure. So what's Service Fabric? Service Fabric, it provides runtime capabilities and life cycle management to applications that are composed of microservices, no infrastructure management at all. And with Service Fabric, we can easily scale the application to tens or hundreds or even to thousands of machines. Here, machines represent containers. As next thing in compute domain, let's talk about virtual machine scale set. Now, this virtual machine scale set, it lets us to create a group of identical load balanced VMs. I just want to mention it again. It helps us to manage a group identical and load balanced VMs. The number of instances or the number of VM instances in a scale set can increase or decrease in response to the demand, or in response to a schedule that we define. The resources needed on a Monday morning is not the same as that would be required on a Saturday or a Sunday morning. All right. And even within the day, the resources that would be needed in the beginning of the business hour is not the resources that would be needed at noon or after 8 or 9 in the evening. So the demands could actually vary in the environment, and this scale set helps us to take care of the varying demand, or take care of the different infrastructure requirement at a different schedule throughout the day, throughout the week, throughout the month, or could be throughout the year as well. The skill set also allows us to provide high availability to our applications, and it helps us to centrally manage, configure, and update a large number of VMs as if they are just one thing. Now you might ask, well, virtual machines are enough. Why would we need a virtual machine skill set? Just like I said, this virtual machine skill set helps us with a greater redundancy and improved performance for our applications. And those applications can be accessed through a load balancer that actually distributes the requests to the application instances. So in a nutshell, this virtual machine scale set, it helps us to create a large number of identical virtual machines, number one. And with scale set, we can increase or decrease the virtual machines. With virtual machine scale set, we can centrally manage and configure and update a big group of VMs. And it's a great use case when it comes to big data or container workloads. As next thing in compute domain, let's talk about cloud services. Now this Azure Cloud Service is actually a platform as a service, and it's very friendly. In fact, it is designed for applications that support scalability, or an application that requires scalability or reliability, and on top of it, you want them to be very inexpensive to operate. So Azure Cloud Service provides all these. So where would this cloud service run? Well, it runs on a VM, but it's a platform as a service. VMs are infrastructure as a service, and when we run applications on VM through cloud service, it becomes platform as a service. So here is how you got to be thinking. With infrastructure as a service like VMs, we first create and configure the environment, and then we run applications on top of it. Let's look at the responsibility. The responsibility for us in VM is that we manage everything end to end, like deploying new patches, picking the versions of the operating system, and making sure they are intact and all that stuff. It's all managed by us. But on the contrary, with platform as a service, it's as if the environment is already ready. All that you have to do is deploy your application in it and manage the platform. Manage the platform not as an administrator, because all the administration is taken care by Azure, like deploying new versions of the operating system. It's all handled by the Azure. So we deploy the application and we manage the application. That's it. Infrastructure management is handled by Azure. So what does cloud service provide? This cloud service provides a platform where we can write the application code, and we don't have to worry about hardware. Simply hand over the code and cloud service takes care of it. So no worry on the hardware at all. So responsibilities like patching, what do we do if something crashes? How do I update the infrastructure? How do I manage the maintenance or the downtime in the underlying infrastructure? All that is handled by Azure. It also provides a good testing environment for us. We can simply run the code, test it before it's actually released to the production. I want to expand a bit on these testing applications. So this Azure Cloud Service, it actually gives us a staging environment for testing a new release without it affecting the existing release, which actually reduces the customer downtime. So we can run the application, test it, and anytime that's ready for production, all that's needed for us to do to move it to production is simply to swap the staging environment into the production environment, and the old production environment will now become the new staging environment, where we can add more to it and then swap it back at a later point. So it kind of gives us a swappable environment for testing our applications. And not only that, it gives us health monitoring alerts. It helps us to monitor the health and availability of our application. And there is a dashboard we can benefit from when we use Azure Cloud Services, and that shows the key statistics all in one place. And we can also set up real-time alerts to warn when a service availability or a certain metrics that we are concerned about degrades. As next thing in compute domain, let's talk about functions. Now functions are serverless computing. Many times if you heard about Azure being serverless, a lot of time they are referencing, or the person who's talking to you is referencing to serverless computing or Azure Functions, which is a serverless computing service hosted on Microsoft Azure. The main motive of a function is to accelerate and simplify application development. Functions helps us to run code on demand without we need to pre-provision or manage any Azure infrastructure. So Azure Functions are script or a piece of code that gets run in response to an event that you want to handle. So in short, we can just write a code that you need for a problem at hand without actually worrying about the whole application or the infrastructure that will be running that code. And the best of all the best is when we use functions, we only pay for the time that our code runs. So what does functions provide, or what does Azure Functions provide? Azure Functions allow users to build applications using serverless, simple functions with a programming language of our choice. So the current programming languages that are supported is C#, F#, Node.js, Java, and PHP. So here we really don't have to worry about provisioning or maintaining servers. If a code requires more resource, yes, Azure Functions handles or it provides the additional resources needed by the code. And the best part is we only pay for the amount of time the functions are running, not the resources, but the amount of time the function is running. As next thing, and moving to the new domain, let's talk about the container domain in Azure. Now the container domain or the container service, it allows us to quickly deploy a production ready Kubernetes or a Docker Swarm cluster. Now what's a container? A container is a standard unit of software that packages up code and all its dependencies so the applications run quickly and reliably from one computing environment to another. It could be testing to staging to development environment to staging to production, or from one production to another production, or on-premises to cloud, or one cloud to another cloud, vice versa. Now imagine we had an option not to worry about the VM and just focus on the application. Well, that's exactly what containers helps us achieve. So these container instances enable us to focus on applications and not worrying about managing VMs or not worrying about learning the new tools required to manage the VMs or even the deployment. And our applications that we create, they run in a container. And running in a container is what helps us to achieve all these, not being able to manage or not needing to manage the virtual machines. So these containers, they can be deployed into the cloud using a single command if you're using a command line interface, and a couple of button clicks if we are using the Azure portal. And these containers are kept lightweight, but they are equally secure as virtual machines. Let's talk about container service as next thing. The container service, or sometimes called as Azure Kubernetes service, it helps us to manage the containers. Container is one thing, and a service that's used to manage the container is another thing. Now this Kubernetes service, or ACS, it helps us to manage the containers. So let's expand on this a bit. So this Azure Container Service, or ACS, it actually provides a way to simplify the creation, configuration, and management of a cluster of virtual machines that are pre-configured to run containerized applications on top of them. Deploying these containers might take like 15 to 20 minutes, or deploying the virtual machines that run containers in it might take 15 to 20 minutes. And once they are provisioned, we can actually manage them by using simple SSH tunnel into them. And this ACS, when it runs applications from Docker images. What does that mean? Docker images makes sure that the applications the container runs are fully portable. Images are portable. And ACS also helps us to orchestrate the container environment. Not only that, it also helps us to ensure that these applications that we run in containers can be scaled to thousands or even tens of thousands of containers. So in a nutshell, managing an existing application into a container and running it using AKS or ACS is really easy, or that's what it is all about, to make the application management or migration easy. Now, managing the container based architecture, and we discussed that containers could be tens or even tens of thousands of containers. So managing them is made simple using this container services. And even training of model using a large data set in a complex and resource intensive environment, this AKS helps us to simplify that environment. Alright, as next thing in container domain, let's talk about container registry. We spoke about registry a little bit when we spoke about Docker images. So container registry is a single place where we can store our images, which are Docker images. When we use containers, it's Docker images that we use for our image purposes. So these container images are a central registry that can be used to ease container development by easing the storage and management of container images. So there we can store all kind of images like Docker Swarm, or the images used in Docker Swarm are in Kubernetes. Everything can be stored in container registry in Azure. Now, anytime we store a container image, it provides us an option for geo replication. What that means is that we can efficiently manage a single registry replicated across multiple regions. Now, these geo replication, it actually enables us to manage global deployments, assuming we are having an environment that requires a global deployment. So it helps us to manage global deployments as one entity because we are geo-replicating. We would be updating, we would be editing one image, and that image gets replicated throughout the global replication centers we would have set up. And so just one editing would have actually edited the global images, and those global images would have provisioned the global application. So one edit, replication, and then provisioning of the applications global wide. And this replication also helps us network latency, because anytime an application needs to deploy, it does not have to rely on a single source which can be reached only through high latency network. Because we have global replications around the world, anytime the application wants to check back, it would check back the application which is in a very nearby location for the application itself. Global replication means that we are managing it as a single entity that's being replicated across the multiple regions in the globe. As next thing in our learning, let's talk about Azure databases. Now, this Azure databases are relational. In fact, they have many flavors in them. We're going to look at different flavors, SQL, NoSQL, cache type of database that Azure offers. So we're going to learn one at a time, or we're going to learn one by one. So this Azure SQL database is a relational database. In fact, it's a relational database as a service. It's managed by Azure. We don't get to do a lot of management in it. So it's a relational database as a service based on Microsoft SQL Server database engine. And this database is a high performance database. It's very reliable, and it's very secure as well. And this high reliability, high performance, and for this high security, we really don't have to do anything. It comes along with it, and it's managed by Azure. And there are two things that I definitely need to mention about Azure SQL database. That is, it's an intelligent service. Number one, it's fully managed by Azure, and it also has this one good thing, which is it has built-in intelligence that learns app patterns and adapts to maximize performance and reliability and data protection of the application. That's something that's not found in many of the other cloud providers that I'm aware of. So I thought I'll mention it. So it uses built-in intelligence to learn about the user's database patterns and helps improve performance and protection. And migration or importing data is very easy when it comes to Azure SQL database. So it can be readily or immediately used for analytic reporting and intelligent applications in Azure. As next thing, let's talk about Azure Cosmos DB. Now, Azure Cosmos DB is a database service that is for NoSQL type, and it's created to provide low latency and an application that scales dynamically or that scales rapidly. Now, this Azure Cosmos DB is a globally distributed service, and it's a multi-model database. This can be provisioned in a click of a button. That's all we got to do if we need to provision an Azure Cosmos DB in the Azure. It helps with scaling the database. We can elastically and independently scale throughput and storage across this database and in any of the Azure geographic regions. It provides a good throughput, it provides good latency, it provides good availability, and it provides, or Azure promises, a comprehensive SLA that no other database can offer. That's the best part about Cosmo DB. So this Cosmo DB was built with global distribution in mind, and it's built with the horizontal scale in mind. And all this we can use by only paying for what we have used. And remember, the difference between Azure Cosmo DB and the SQL database is that Azure Cosmo DB supports NoSQL, whereas SQL doesn't. Alright, few other things about Azure Cosmo DB is it allows users to use key value, graph, column, family, and document data. It also gives users a number of API options like SQL, JavaScript, MongoDB, and few others that you might want to check in the document at the time of reading. And the best part here is that all that we mentioned, we get to use only by paying for the amount of storage and throughput that are required. And the storage and the throughput can be elastically scaled based on the requirement of that R. Alright, let's talk about Redis cache. Discussion about Azure database won't be complete without we talking about Redis cache. Now Redis cache is a secure data cache. It's also sometimes called as messaging broker that provides high throughput and low latency access to data for the applications. Now Redis cache is based on a popular open source caching product, which is Redis, sometimes called as Redis cache. Now what's the use case? It's typically used to cache to improve the performance and scalability of a system that rely heavily on backend data stores. Now performance when we use Redis cache is improved by temporarily copying the frequently accessed data to a fast storage located very close to the application. Now with Redis cache, this fast storage is located in memory with Redis cache instead of being loaded from the actual disk in the database itself. Now this Redis cache can also be used as an in-memory data structure store. Not only that, it can be used as a distributed non-relational database and a message broker. So there are a variety of use cases for this Redis cache. And by using Redis cache, the application performance is improved by taking advantage of the low latency and the high throughput performance that this Redis cache engine provides. So to summarize, this Redis cache, when we use Redis cache, data is stored in the memory instead of the disk to ensure that there is high throughput and low latency when the application needs to read the data. It provides various levels of scaling without any downtime or interference. Now this Redis cache is actually backed by Redis server, and it supports string, hashes, linked list, and various other data structures. Now let's talk about security and identity services. Now identity management in specific is a process of authenticating first and then authorizing using security principles. And not only that, identity management involves controlling information about those principal identities. You might ask, now what's a principal identity? Now identity or principal identity are services, applications, users, groups, and a lot more. The speciality about this identity management is that it not only helps authenticate and authorize principals in cloud, it also helps authenticate and authorize principals or resources on premises, especially when you run an hybrid cloud environment. So all these services and features that this identity management helps us to get additional level of validation, like identity management can provide multi-factor authentication. It can provide access policies based on condition, permit or deny based on condition. It can also monitor suspicious activity, and not only that, it can also report it. It can also help generate alerts for potential security issues, and in a way to mitigate it, can send us an alert so we can get involved and prevent a security accident from happening. So let's talk more about identity management. So some of the services under security and identity management are Azure Security Center. Now this Azure Security Center provides security management and threat protection across the workloads in both cloud and in the hybrid environment. It helps control user access and application control to stop any malicious activity if present. It helps us to find and fix vulnerabilities before they can be even exploited. It integrates very well with analytic methods that helps us to identify, or it gives us the intelligent to identify or detect attacks and prevent them before it can actually happen. And it also works seamlessly with hybrid environments. So you don't have to have one policy for on-premises and one policy for the cloud. It's now a unified service, both for on-premises and the cloud. The next service in security and identity would be Key Vault. Now, a Key Vault is a service or a feature that helps safeguard the cryptographic keys and any other secrets used by the cloud applications and the services. In other words, this Azure Key Vault is a tool for securely storing and accessing the secrets of the environment, the secret keys. Now, a secret is anything that you really want to have a very tight control access, like the certificates, like the passwords, stuff like that. Now, if I tell you what Key Vault actually solves, that would actually explain what Key Vault is. Now, Key Vault is used in secrets management. It's helped in securely storing the tokens, the passwords, the certificates. It helps in key management. It really helps in creating and controlling the encryption keys that we would use to encrypt data. It helps in certificate management. Talking about certification management, it helps us to easily provision, manage, and deploy public and private SSL, TLS certificates in Azure, and a lot more. So in a nutshell, this Key Vault, it provides users the ability to provision new vaults and keys in just a matter of minutes. All that in a single command, or all that in a couple of button clicks. It also helps users to centrally manage their keys, secrets, and policies. Next in the list, let's talk about Azure Active Directory. Now, Azure Active Directory, it helps us to create intelligent-driven access policies to limit resource usage and manage user identities. What does that mean? Now, this Azure Active Directory is a cloud-based Active Directory and identity management service. Now, Azure Active Directory combines, it's actually a combination of the core directory services plus application access management plus identity protection. And one good thing about this Azure, in fact, there are a lot of good things, but especially when you're running hybrid environments, you might wonder, well, how this Azure Active Directory is going to behave. Now, this Azure Active Directory is built to work on-premises and cloud environment as well. Not only that, it also works seamlessly with mobile applications as well. So in a nutshell, this Azure Active Directory, it acts as an central point of identity and access management for our cloud environment. It also provides good security solutions that protect against unauthorized access of our app and the data. Now that we've discussed about security and identity, let's talk about the management tools that Azure has to offer. Azure provides built-in management and account governance tools that helps administrators and developers, that helps them to keep their resources secure and very compliant. And again, it helps both in on-premises and in the cloud environment. And these management tools help us to monitor the infrastructure, monitor the applications. It also helps in provisioning and configuring resources. It also helps in updating apps. It helps in analyzing threats, taking backup of the resources, build disaster recoveries. It also helps in applying policies and conditions to automate our environment. We use Azure management tools, and it's also used in cost control methods. So this Azure management plays a wide role across the Azure services. And in the management tools, first comes the Azure Advisor. Now this Azure Advisor, it acts as a guide to educate us about Azure best practices. It throws recommendations that we can select on the basis of the category of service, and it also provides the impact it can have, or the impact that would happen in our environment if we follow the recommendations given. And recommendations are, first one is the recommendations are kind of templatized, and it throws the templatized recommendations. Not only that, it also provides customized recommendations on the basis of the configuration, on the basis of our usage patterns. And these recommendations are not hard. It's not like something that it recommends and then just leaves us hanging there. These recommendations provided are very easy to follow, very easy to implement and see results. You can think of Azure Advisor as a very personalized cloud consultant that helps you to follow best practices to optimize our deployments. It kind of analyzes our resources, our configurations, our usage, and then it recommends a solution for us that really helps in improving the cost effectiveness, improving the performance, improving high availability, and improving security in our Azure environment. So with this Azure Advisor, we can get a proactive, actionable, and personalized best practice recommendations. Now, you don't have to be an expert. Just follow the Azure Advisor and your environment is going to be good. It also helps in improve the performance, security, high availability of our environment. And also it helps in bringing down the overall Azure spend. And the best part is it's a free service that analyzes our Azure usage and provides recommendations, how we can optimize our Azure resource to reduce cost. And reduce cost at the same time boost the performance, helps in strengthening the security and improve the overall reliability of our environment. Next in the list would be Network Watcher. Now, this Network Watcher helps users identify and gain insights in the overall network performance and the health of the overall environment. Now, these Azure Watchers provides enough tools to monitor, to diagnose, to view the metrics, and to enable or disable logs, which means to generate and collect the logs for resources in the Azure Virtual Network. So with Network Watcher, you can monitor and diagnose issues in networking without even logging into the virtual machines. With just the logs, which are real-time, we can actually come to a conclusion what could be wrong in a certain resource, in a VM or in a database, by just looking at the logs. And not only that, it's used for analytic or to gain some intelligence of what's happening in our network. We can gain a lot of insight to the current network traffic pattern using the security group flow logs that this Network Watcher offers. It also helps in investigating VPN connectivity issues using detailed logs. Now, you might or might not know that VPN troubleshooting requires both parties, or it involves two parties. The person, the network administrator on this side and the network administrator on the other side. And they will have to check logs in their end and we'll have to check logs in our end, stuff like that. But with the Network Watcher, it kind of takes it to the next level. The logs itself, we could easily identify which side is having the issue and suggest an appropriate fix. And the next in the list would be Microsoft Azure Portal. Now, this Microsoft Azure Portal, it provides a single unified console to perform various number of activities like building, not only building, managing and monitoring the web applications that we build. Now, this portal can be used to organize our environment or the appearance of the environment or the visual of the environment based on our work style. And using Azure Portal, users can control who gets to manage or access the resources, all from the Azure Portal. And this Azure Portal gives a very good visibility on the spends that happen on each resource, right? And if we can customize it, we can also identify spends based on team, spends based on days, spends based on department, stuff like that. So it kind of gives us a good visual of where the money is spending or where is the bill consumed within the Azure environment. Next in the list would be Azure Resource Manager. Now, Azure Resource Manager enables us to manage the usage of the application resources. Now, we use Resource Manager to deploy, monitor, and manage solution resources as a group, as if it's one single entity. Now, the infrastructure of our application is typically made of various components, which includes virtual machine, storage, virtual network, web app, database servers, some other third-party services that we might use in our environment. and they are by nature separate services. But with Azure Resource Manager, we don't see them as different components or different entities. Instead, we see them as related services in a group that supports an application. Now we kind of get the relation between them instead of letting them spread. Azure Resource Manager identifies the relation between them and helps us to visually see them all as one or single entity. Not only that, Azure Resource Manager helps, or it ensures that the resources that we provision are deployed at a constant rate along with the other application. It also helps users to visually see their resources and how they are connected, and that helps in managing the resources a lot better. Resource group also is used to control who can access the resources within the user's organization. Kind of gives you the fine-grained control over who gets to access and who does not get access. And the last one in the management tools would be automation. And this automation gives us the ability to automate, configure, and install upgrades across hybrid environments. It provides a cloud-based automation and configuration service. Not only that, this can be applied for non-Azure environments as well, which is on-premises. So some of the automation we could do is process automation, update management automation, configuration features automation, stuff like that. And this Azure automation provides complete control during the deployment, operation, and also during the decommissioning of the workloads and resources. With automation, we can actually automate time-consuming or mundane or any task that's error-prone because of human errors. Those things can be automated. So irrespective of how many times you run it, it's going to run the same way. And that really helps in reducing the overall time and also the overhead cost, because a lot of the things are automated, which means it's human error-free, which means the application is not going to break and keep running for a longer time. With automation, we can actually build a good inventory of operating system resources and configuration items all in one place with ease. And this really helps in tracking the changes and investigating the issue. Let's say something happened. Because we have automation, because it's logging the configuration changes, it's easy to track, easy to identify what has changed lately that has broken the environment, go back and fix it or kind of roll it back. That solves the problem. And that actually summarizes the Azure management tools or management services. Now let's talk about the networking tools or the networking services available in Azure. There are a variety of services, especially networking services, that Azure offers, and I'm sure it's going to be an interesting one. Let's begin our discussion with Content Delivery Network. Now, the Content Delivery Network, in short CDN, it allows us to perform secure and a very reliable content delivery. Not only that, it also helps in accelerating the delivery time, or in other words, reducing the delivery time, also called as load times. It also helps in saving bandwidth and increases in responsiveness to the application. Let's expand on this. The Content Delivery Network is actually a distributed network of servers that can efficiently deliver web content to users. Now, CDNs, we're going to use the word CDN here. CDNs store cached content on global edge servers, also called as POPs, point of presence locations, that are very close to the end users, so the latency is minimized. It's like taking a copy of the data or taking a multiple copy of the data and storing it in different parts of the world, and whoever is requesting it, the data gets delivered to them from a server which is very locally to them. So this CDN offers developers a global solution for rapidly delivering high bandwidth content to users by caching the content in a strategically placed location which is very near to them. So these content delivery networks, it really helps in handling. That's one advantage you get for content delivery network, that's we can handle spikes and heavy loads very efficiently. And we can also run analytic against the logs that gets generated in content delivery network, which helps in gaining good insight on the workflow and what would be the future business need for that application. And this, just like a lot of other services, this is on a pay-as-you-go type. So you use the resource first and then you only pay for what you have used. The next one in networking would be ExpressRoute. Now, ExpressRoute is actually a circuit or a link that provides a direct private connection to Azure. And because it's direct, it gives low latency link to Azure. It gives good speed and reliability for the Azure data transfer. It could be on-premises to Azure. So it gives very good speed. It gives increased reliability and low latency for that connection. Let's expand on this a bit. Now, this ExpressRoute is a service that actually provides a private connection between Microsoft data center and infrastructure in our premises or in a different co-location facility that we might have. Now, these ExpressRoutes do not go over the public internet. And because they don't go over the public internet, they offer a high security, reliability, and speed and low latency compared to the connections which are in the internet. Because it's fast, because it's reliable, because it has low latency, it can be used as an extension of our existing data center. Users are not going to feel the difference whether they are accessing services from an on-premises or in the cloud environment, because latency is minimized as much as possible. Users are really not going to see the difference. And because it's a private line and not a public internet line, it can be used to build hybrid applications without compromising privacy or the performance. Now, these virtual private cloud, these ExpressRoutes can be used for taking backups. If assume a backup going through the internet, that would be a nightmare. If you use ExpressRoute for backups, that's going to be fast. And imagine recovering a data through the internet, from the cloud, through the internet, to the on-premises in a time of disaster. That would be the worst nightmare. So these ExpressRoutes can be used not only to backup, but also to recover the data. Because it provides good speed, low latency, recovering the data is going to be a lot sooner. The next product or service we're going to discuss in networking is Azure DNS. Now, Azure DNS allows us to host domain name in Azure, and these domain names come with an exceptional performance and availability. Now, Azure DNS is used to set up and manage DNS zones and records for our domain name in the cloud. Now, this Azure DNS is a service for DNS, just like the name says, and it provides name resolution by using Azure's infrastructure. And by using this domain, we can actually manage the DNS ourselves through the Azure portal with the same credential. Imagine having a DNS provider which does not even belong in our IT. Imagine that environment. We would have a separate portal to manage the DNS environment. Now, those are gone. And now we can actually manage the DNS in the very same Azure portal where we use the rest of the other services. And this Azure DNS very much integrates with other DNS service providers. It uses a global network of name servers to provide fast response to DNS queries. And these domains are having additional availability compared to the other domain service providers' availability promises. These are going to have more availability than the rest because most of the servers are maintained by Microsoft, and it helps resolve sooner. It helps resyncing. Let's say a server fails, it kind of helps resyncing with the rest of the servers. So all the Microsoft's environment, all the Microsoft's global network of name servers kind of ensures that our domain names are resolved properly, not only properly, but also are available most of the time. Right, next in the list in networking services is virtual network. I'm sure this is going to be very interesting and I'm sure you're going to like it. So this networking or virtual networking in Azure, it actually allows us to set up our own private cloud in the public cloud. It gives us an isolated and highly secure environment for our application. Let's expand on this. So this Azure Virtual Network helps us to provision Azure virtual machines and it helps us to securely communicate with other on-premises and internet networks. It also helps in controlling the traffic that flows through or flows in and out of this virtual network to other virtual networks and to the internet. Now this Azure virtual network, sometimes called as VNet, is actually a representation of our own network in the cloud. It's actually a logical isolation of the Azure cloud dedicated to our subscription. All our environments are provisioned in a VNet that is separate from another customer's VNets. That way we have that logical separation there. So this virtual network can also be used to provision VPNs in the cloud, so we can connect the cloud and the on-premises infrastructure and a lot more, especially in an environment where we have hybrid environment. Surely we will be using virtual network because that's going to require a VPN for secure data transfer in and out of the cloud and in and out of the on-premises environment. Alright, so it kind of gives us a boundary for all the resources. So all the traffic between the Azure resources, they kind of logically stay in between or logically stay within the Azure virtual network. And here we can design the network. It's given over to us. You can pick the IP, you can pick the routing, you can pick the subnet. A lot of freedom is given, or I would say a lot of control on how the network is designed. It's not like something that's already cooked and we only get to use it. No, we can actually build the network from the scratch. We can pick the IP address that we like. We can pick which subnet needs to communicate with the other subnet, stuff like that. And like I said, if you are using hybrid environment, you definitely would be requiring a virtual network because it helps connect the on-premises and the cloud in a secure fashion using VPN. The last product we're going to discuss in networking is a load balancer. This load balancer actually provides application a good availability and a good network performance. So how does it work? It actually works by load balancing the traffic to and from the virtual machine and the cloud resources. Not only that, it also load balances between cloud and cross-premises virtual networks. With Azure Load Balancer, we can actually scale our application and create high availability for our services, which means our application will be available most of the time. If any of the server goes dead, the server does not get traffic. What happens if the server gets traffic? User is going to experience downtime. What happens if the server does not get traffic? User won't experience any downtime. The connection is shifted to an healthy service, so the user experiences uptime all the time. So this load balancer supports inbound and outbound scenarios, and it provides low latency. It gives high throughput of the data transfer, and we can actually scale up the flow of the TCP and UDP connections from hundreds to thousands to even millions because we have a load balancer now in between the user and the application. So how does it operate? This load balancer actually receives the traffic and it load balances the traffic to the backend pool of instances connected to it according to the rule and the health probe that we set. That's how it maintains high availability. So what does load balancer help? It helps in creation of high available scalable application in the cloud in minutes. It can be used to automatically scale the environment with the increasing application traffic. And one feature of load balancer is to check the health of the user's application instance, and it removes or it stops sending the request to the unhealthy instance and kind of shifts that connection to the healthy instance. That way a user or a connection does not get stuck with an instance that's not healthy. That's all that you need to know about the networking services. Now let's talk about the storage services or the storage domain in Azure. Now Azure Storage in general is a Microsoft managed service providing cloud storage, which basically is highly available, secure, durable, scalable, and redundant because it's all managed by Azure. We don't get to manage a lot of it. And these Azure storages are a group of storage services. They cater different needs. And the storage products include Azure Blobs, which is actually an object storage. It includes Azure Data Lake. It includes Azure Files. As you see, it includes Azure Queues. It includes Azure Tables and a lot more. But let's start our discussion with Azure Store Simple. Azure Store Simple is an hybrid cloud storage solution that actually lowers the cost of storage to nearly 60% of how much you would be actually spending without using it. So Azure Simple Storage or Store Simple is an integrated storage solution that manages the storage task between on-premises and the cloud storage. What I really like about Azure is that it's built around a hybrid environment in mind. There are a lot of other cloud providers that are there where running an hybrid environment is a big challenge. It has some compatibility. You won't be able to find an hybrid or a on-premises and cloud solution for your need, stuff like that. But with Azure, especially when it comes to storage, a lot of the things that we're going to see, it clearly is designed with hybrid environment in mind. All right, so let's come back and talk about Store Simple. So Store Simple is an very efficient, cost-effective, and a very easily manageable SAN, storage area networking solution in the cloud. I thought I'll throw in this information. The reason why it got Store Simple is really because it uses Store Simple 8000 series devices which are used in Azure Data Center. And this Store Simple or Simple Storage, it comes along with storage tiering to manage the stored data across the various storage media. So the very current data is actually stored in on-premises on solid state drives, and data that is used less frequently is stored in HDDs or hard disk drives. And the data that requires archived or that needs to be archived, very old data, let's say less frequently used data, candidate for archive, they are actually pushed to the cloud. So you see how this storage tiering automatically happens in Store Simple. And another cool feature of Store Simple is that it enables us to create an on-demand and scheduled backups of data and then store the data locally or in the cloud. And these backups are actually taken in the form of incremental snapshot, which means that they can be created and restored quickly. It's not a complete backup, it's an incremental backup. And these cloud snapshots, they can be critically important when there is a disaster and when there is a disaster recovery scenario, because these snapshots can be called in and they can be put on storage systems and then they become the actual data. So recovering is faster if you have proper scheduled backups or if you have frequent backups. And this Storage Simple, it really helps in easing our backup mechanism, which means it kind of eases our disaster recovery steps or procedures as well. So this Store Simple, it can be used to automate data management, data migration, data movement, data tiering across the enterprise, both in cloud and on premises. It actually improves the compliance and accelerates the disaster recovery for our environment. And if there is one thing that's increasing every new day in our environment, that would be storage. And this Store Simple addresses that need, and we really don't have to pre-plan or think in deep for having a proper storage, because now we have a simple storage available in the cloud, and moreover it's on a pay-as-you-go type. So not much pre-planning on storage is needed. Yes, there will be a need, but not as much as I would without the cloud or without the simple storage. And the next service under storage that we would like to discuss is the Data Lake Store. This Data Lake Store or storage, it's a cost-effective solution for big data analytics in specific. So let's expand this. So this Data Lake Storage is an enterprise-wide repository for big data analytic workload. Now that's the major service that's dependent on this Data Lake Store. And this Data Lake enables us to capture data of any size, of any type, and of any ingestion speed, and it kind of collects them in one single space or in one single place for operational efficiency. And for analytic purpose. Hadoop in Azure is very dependent on this Data Lake Storage. And this Data Lake Store is designed with performance for analytics in mind. So anytime you think of, or anytime you're using analytic in the cloud, or anytime you're using Hadoop in the cloud in Azure, we are definitely using, or we will be to the most part, or the normal procedure, or the right storage to pick would be data lake store in Azure. It's designed with security in mind. So anytime we use Azure storage, we can be rest assured that we are using storage from within a data center which was built with security in mind. So this data store also uses Azure Blob storage behind the scenes for global scale, durability, and for performance. Let's talk about blob storage. Now, blob storage provides large amount of storage and scalability. Now, this blob storage is the object storage solution for Azure Cloud. Let's expand a bit on blob storage. Azure Blob Storage is Microsoft offering for object storage. Now, this blob storage is optimized for storing massive amount of unstructured data, which could be text or binary data. It's designed and it's optimized for rapid reads. If I explain to you on what scenarios we would be using blob storage, that might help you get a good understanding of what blob storage is. So it's designed, as of now it's being used in many IT environments to serve images or documents directly to the browser. It helps in storing files for distributed access. A lot of fetchers can fetch data from Azure Blob Storage. And it's currently helping users stream video and audio. It's currently being used for writing log files. It's currently being used to store data as backup and restore at a later point in times of disaster recovery. It also is used as an archiving storage in a lot of cloud IT environments. It's widely used in storing analytic data, not only storing but also running analytic query against the data stored in it. So that's a wide use case for blob storage. Not only that, in addition to all that we mentioned, it also supports versioning. So anytime somebody updates an data, a new version gets created, which means at any point I can roll back as and when needed. And it provides a lot of flexibility on optimizing the user's storage need. It also supports tiering of the data. So based on need, when I actually explore, I would find a lot of options I can pick from that suits to my unique storage environment or unique storage need. And like I said, it stores unstructured data, and this unstructured data is available for customers through REST-based object storage environment. The next product and storage service would be queue storage. Now, queue storage provides durable queues for large volume cloud services. It's a very simple and a cost-effective, durable messaging queue for large workloads. Let's expand this queue storage for a moment. Now, this queue storage is a service for storing large amount of messages that can be accessed from anywhere in the world through HTTP and HTTPS calls. A single queue or a single queue message can be up to like 24 KB in size, and a single queue can contain millions of such 24 KB in size messages. And how much can it hold? It can hold up to the total capacity of the storage account itself. So that's kind of easy to translate. How much would it hold? And this Azure Queue Storage, it provides an messaging solution between applications and components in the cloud. What does it help? It helps in designing an application for scale. It helps in decoupling the application. So, it's not very dependent, or sometimes it's not at all dependent on the other application, because now we have a queue in between which kind of translates or which kind of connects or which kind of decouples both the environment. Now we have a queue in between. Both the environment can scale up or scale down independently. The next in the storage service would be file storage. Let's talk about file storage. Now, these Azure files provide secure, simple, and managed cloud file shares. Now, with file share in the cloud, it actually extends the user's server's on-premises performance and capacity. And a lot of familiar tools for the cloud file share management can be used along with the file storage that we're talking about. So let's expand a bit on file storage. Now, this Azure Files or Azure File Storage offers a fully managed file shares in the cloud that can be accessed via the SMB protocol. So server message block protocol. Now this Azure file shares can be mounted concurrently by cloud or in on-premises deployments. A lot of operating systems are compatible with it. Windows are compatible, Linux is compatible, Mac OS is compatible. In addition to all this being able to run on-premises and on the cloud, or being able to access from on-premises and on the cloud, it can also offer cache for caching the data and keeping it locally, so it's immediately available when needed. So that's some additional feature, I would say that's some advanced feature that it offers compared to the other file shares available in the market. Let's talk about table storage. Now, table storage is a NoSQL key value pair storage for quick deployments with large semi-structured data sets. The difference between one important thing to note with table storage is that it has a flexible data schema, and also it's highly available. Let's expand a bit on table storage. So anytime you want to pick a schema-less, a NoSQL type table storage is the one we'll end up picking. It provides an key pair attribute storage with a schema-less design. This table storage is very fast and very cost effective for many of the applications, and for the same amount of data, it's a lot cheaper when you compare it with the traditional SQL data or data storage. So some of the things that we can store in the table storage are, of course, they're going to be flexible data sheets, such as user data for web application, address books, device information, and other types of metadata for our service requirements. And it can have any number of tables up to the capacity limit of the storage account. Now this is not possible with SQL. This is only possible with NoSQL, especially with table storage in Azure. Explanation of storage really concluded the length and breadth of the explanation this CEO was giving his IT personnel. But this IT personnel is not done with it yet. He still has a question even after this lengthy discussion, and his question was, well, there are a lot of other cloud providers available. What made you specifically choose Azure? I mean, from the kind of question that he asked, we can say that he is very curious, and he definitely had asked a very thoughtful question. So his CEO went on and started to explain about the other capabilities of Azure, or how it kind of outruns the rest of the cloud providers. So he again started his discussion, but from a different angle now. So he started to explain what are the capabilities, or how Azure is better than the competitors. So he started with explaining the platform as a service capabilities. And I'm going to tell you what the CEO told his IT person. So this platform as a service, or in platform as a service, the infrastructure management is completely taken care by Microsoft, allowing users to focus completely on the innovation. No more infrastructure management responsibilities. Go and focus on innovation. That's a fancy way of saying it. When we buy platform as a service, that's what we get. We can contribute our time on innovation and not just maintaining the infrastructure. And Azure especially is .NET friendly. Azure supports the .NET programming language, and it is built or designed, or it is optimized to work with old and new applications deployed using .NET programming framework. So if your application is .NET, most of the time you would end up picking Azure. I mean, if you try to compare, most of the time you would end up picking Azure as your cloud service provider. And the security offerings that Azure offers is it's designed based on the security development lifecycle, which is an industry-leading assurance process. When we buy services from Azure, it assures that the environment is designed based on security development lifecycle. And like I mentioned many times in the past, and I would like to mention it again, Azure has well thought about the hybrid environments, which a lot of other cloud providers have failed. So it's very easy to set up an hybrid environment, to migrate the data or not to migrate the data and still run a hybrid environment. They work seamlessly with Azure, because Azure provides seamless connection across on-premises data centers and the public cloud. It also has a very gentle learning curve. If you look at the documentation, it's picture rich, and the documentations are neat and clear. It would encourage you to learn more. It would encourage you to think and imagine and try easily get a grasp of how services work. So it has a very gentle learning curve. Azure allows the utilization of technologies that several businesses have used for years. So there is a big history behind it. It has a very gentle learning curve. The certifications, the documentations, the stage-by-stage certification levels, it's all very gentle learning curve, which is generally missing in other cloud service providers. Now, this would really impress the CTOs or people working in finance and budgeting. If an organization is already using Microsoft software, they can definitely go and avail or be bold and ask for a discount that can reduce the overall Azure spending. In other words, overall pricing of the Azure. So that's what helped, or they are the information that helped the CEO pick Azure as his cloud service provider. And then the CEO goes on and talks about the different companies that are currently using Azure, and they are definitely using Azure for a reason, like Pixar, Boeing, Samsung, EasyJet, Xerox, BMW, 3M. They are major multinational, multi-billion companies. They rely, run, operate their IT in Azure. And this CEO has a thought that his IT person is still not very convinced unless and until he shows him a visual of how easy things are in Azure. So he goes on and explains about a practical application of Azure, which is what exactly I'm going to show you as well. All right, a quick project on building an Azure app using or building a .NET application in Azure Web App and making it connect to an SQL database will solidify all the knowledge that we have gained so far. So this is what we're going to do. I have an Azure account open, as you see, logged in, and everything is fresh here. Let me go to resource group. There's nothing in there. It's kind of fresh. All right, I'm logged in, and this is what we're going to do. So we're going to create an application like this, which is nothing but an to-do application, a to-do list application, which is going to run from the web app, get information from us, and save it in the database that's connected to it. So you can already see it's a two-tier application, web and DB. All right. So let me go back to my Azure account. The first thing is to create an resource group. Let's give it a meaningful name. Let's call it Azure Simplilearn. All right. And it's going to be a free trial. And the location, pick one that's nearest to you, or wherever you want to launch your application. Now for this use case, I'm going to pick Central US and create. It's going to take a while to get created. There you go. It's created. It's called Azure Simplilearn. Now what do we need? We need an web app and a separate SQL database. Let's first get our web app running. So go to App Services and then click on Add. It's not the web app plus SQL that we want. We want web app alone for this example. So let's create an web app. Give it a quick name. Let's call it Azure Simplilearn. The subscription is free trial. And I'm going to use my existing resource group, a resource group that we created some time back. It's going to run out of Windows, and we're going to publish the code. All set, we can create it. All right, while this is running, let me create my database. Right, SQL database, create a database, give it a name. Let's call it Azure Simplilearn DB. Put it in our existing resource group that we created. It's going to be a blank database, right? And it's going to require some settings like the name of the server and the admin login, the password that goes along, and in which location this is going to be created. The server name is going to be Azure Simplilearn DB. That's the server name. And the admin login can be, what can be the admin login name? Let's see. So let's call it Simplilearn. That's my admin login name. And let me pick a password. Click on create. So what have we done so far? We have created an web app. and we have created a database in the resource group that we have created. So if I go to resource group, it's going to take some time before things show up. So if I go to my resource group, I only have one resource group as of now, Azure Simplilearn, and there I have a bunch of resources being created. It's still being created. Right. In the meantime, I have my application right here that's running out of or that's in Visual Studio as of now. Right. So once the infrastructure is set and ready in the Azure console, we're going to go back to Visual Studio, feed these inputs in the Visual Studio so the code knows what the database is, the credentials to log into the database, stuff like that. So we're going to feed those information in Visual Studio. By that, we're actually feeding it into the application, and then we're going to run it from there. Deploying these applications takes quite a while. We really got to be patient. Right, now we have all the resources that we need for the application to run. Here's my database, and here's my app service. There's one more thing we need to do, that is create an firewall exception rule. So one more thing needed is to create an firewall exception rule, right? So the application is going to run from my local desktop, and it's going to connect to the database, right? So let's add an exception rule by simply adding the client IP. It's going to pick my IP, the IP of the laptop I'm using as of now, and it's going to create an exception to access the database. So that's done. Now we can go back to our Visual Studio. I already have a couple of apps running, or a couple of configurations pushed from Visual Studio. I'm going to clean that up. If you're doing it for the first time, you may not need to do this. Alright, so let's start from the scratch. This is very similar to how you would be doing in your environment. Alright, so we're going to select an existing Azure app service. Now before that, I have logged in. As you can see, I have logged in with my credentials. So it's going to pull few things automatically from my Azure account. So in this case, I'm going to use an existing Azure app. So select existing and then click on publish. All right, if you recall, these are the very same resources that we created a while back. Right, we have clicked on save, and it's running, kind of validating the code, and it's going to come up with an URL. Now initially the URL is not going to work because we haven't mapped the application to the database. So that would be the next thing. Alright, so the app has been published and it's running from my web app as of now. It's going to throw an error. Like you see, it's throwing an error. That's because we haven't mapped the app and the DB together. So let's do that. Alright, let's do that. So let's go to Server Explorer. This is where we're going to see our databases that we have created. Now let's quickly verify that. Go back to the resource group, right? Appropriate resource group, which is right here. And here I have my database, Azure Simplilearn database.
Right, it has some issues connecting to my database. Give me a quick moment. Let's fix it. All right, so we'll have to map the database into this application. All right, so let's go to the Solution Explorer, click on Publish, and a page like this gets shown. And from here, we can go to Configure. Here is our web app, all right, with all its credentials. Let's validate the connection, number 1. All right, and then click on Next. This is my DB connection string, right, which the app is going to use to connect to my DB. Now, if you recall, our DB was Azure Simplilearn DB, and that's not being shown here. So let's fix that. Right, so let's fix that. Click on Configure, and here let's put our DB servers URL. Now before that, let's change this to SQL Server. All right, and then in here put the DB's URL. So go back to Azure. Here is my DB or server's name. Put that here. Right, the username to connect to the server, that's right here. Put that in, and the password to connect to the server, let's put that in. Right, it's trying to connect to our Azure portal or the Azure infrastructure, and here is my database. If you recall, it's Azure SLDB. That's the name of the database. Let's test the connection. Connection is good. Click on OK. So now it's showing up correctly. Azure Simplilearn DB, that's the name of the database that we created. Now it's configured. All right, let's modify the data connections. Right, let's map it to the appropriate database again. All right, so our name of the database is Azure Simplilearn DB, and then it's going to be SQL Server. That's the data source. The username is Simplilearn, and the password is what we have given in the beginning. All right, let's validate the connection. It's good. Click OK. Now we're all set and ready to publish our application again. Now the application knows how to connect to the database. We have educated it with the correct connection strings, the DNS name, the username, and the password for the application to connect to the database. So Visual Studio is building this project, and once it is up and running, we'll be prompted with an URL to connect, and anytime we put or we give inputs to the URL, that's going to receive the input and save it in the database. Alright, so here is my to-do list app, and I can start creating to-do list for myself. All right, so I have the items already listed. I can create an entry, and these entries get stored in the database. I can create another entry. Take the dog for a walk. That's gonna get stored. I can create another entry. Book tickets for a scientific exhibition, and that's going to receive and put that in the database. And that concludes our session. So through this session we saw how I can use Azure services to create a web app and connect that to the DB instance, and how those two services which are decoupled by default, which are separate by default, how I can use the connection strings to make connection between the app server and the database and be able to create an working app. I strongly believe you enjoyed me walking you through this session.
I'd like to welcome all of you to this training video on Azure. So here we have two friends having a conversation with each other. One of them says that her company is moving all of its physical data and migrating it onto the cloud. She says that they're using a cloud service provider known as Azure. Now here's the problem. She doesn't really understand how cloud service providers work or even how the cloud does. Her friend decides to help her out. So in this video, here's what we're going to talk about. First, we'll talk about what is cloud computing, what is Microsoft Azure, what are the services that Azure offers, and then we'll have a look at a use case where we'll be applying one of these services to get a particular job done. Now for the first question, what is cloud computing? So cloud computing actually provides a platform through which you can access resources. Now these resources include servers, storage, application security, and other ways you can transform your data or get some use out of it. Now at the same time, you can also store, manage, and process your data. Now anything related to cloud computing is made possible only with the help of the internet. Now along with these things, there are several other things that you can do with cloud computing. Now let's have a look at some of the ways cloud computing is making our lives better. Firstly, you have services for just about every requirement that you have. Then you get access to the newest and most innovative technologies in the market right now. Cloud computing provides cost-effective solutions with flexible pricing. Now most cloud service providers work in such a way that you only pay for the amount of time you use that particular resource. Then you have one of the most important selling points when it comes to cloud computing, which is that data and applications are accessible from any part of the world as long as you have access to the internet. And finally, you have increased protection for your data and applications. Now you should know that there are several cloud service providers in the market right now, be it Amazon Web Services, Adobe Creative Cloud, Google Cloud Platform, and so much more. Now among all these platforms, there's one that's growing really fast, and that is Microsoft Azure. Now let's ask the question, what is Microsoft Azure? Microsoft Azure is actually a cloud service platform that allows users to build, manage, scale, and deploy applications by giving them access to cloud services. Now these cloud services range from creating virtual machines to creating functions that run themselves without having to worry about hardware. Now all of this is made possible only through the internet. Now here are some things that you need to know about Azure. Firstly, it was launched on the 1st of February 2010. It has data centers in more than 42 regions across the world. They also say that 12 more data centers are in the making, which helps them say they're the only cloud service provider that covers these many regions. Next, Azure is preferred by 80% of the Fortune 500 companies, which means that the best of the best in the market only choose to work with Azure. And finally, Azure is the second largest cloud service provider in the market right now. Let's talk about Azure services. As I told you, Azure provides services for a wide range of domains. Now let's have a look at some of these domains. There's AI and machine learning, compute, containers, database, identity, management tools, networking, security, storage, and so much more. Now let's have a look at some of the individual services within these domains. Firstly, you have Azure Virtual Machines. With Azure Virtual Machines, what you get is the opportunity to create Windows or Linux virtual machines. Now all of this is possible in a matter of seconds with a large amount of customization. Now let's have a look at some of its features. Firstly, you can choose from a wide variety of virtual machine options. Then you have a large amount of optimization available to you. For example, what size of operating system do you want? How much size do you want allocated to it? What version of the system is it? And so much more. Then it provides low cost and per minute billing. Now Azure provides you per minute billing, which means that you're only charged for how much time you use the service. And finally, you have enhanced security and protection for your virtual machines. Next, we have Service Fabric. Now with Service Fabric, you have a platform which enables you to create microservices. Now this also makes the process of application lifecycle management a whole lot easier. As a direct result, you can create applications with a faster time to market. It supports Windows, Linux, on-premises or other clouds, and it enables you to do a tremendous amount of scaling up depending on your requirement. And finally, we have functions. Now with functions, you can build applications with the help of serverless computing. Here, the users only pay for the amount of resources that they've used. You can create applications in any language that you want, and the only thing you need to worry about is the code of the application. Everything other than that, that is the hardware requirements, are taken care of by Azure. Now let's have a look at the networking services. Firstly, we have the Azure CDN, or the Content Delivery Network. With Azure CDN, what you get is the ability to deliver your content with reduced load times, fast responsiveness, and less bandwidth. Now, CDN can be integrated with several other Azure services so that the process can move at a faster rate. It can handle heavy loads and traffic spikes with ease. It also provides a robust security system. Now, with the content that's delivered, you can get advanced analytic data with which you can understand how customers are using your content. Next, we have ExpressRoute. With ExpressRoute, you can connect your on-premises network to Azure through a private network. Now, by default, this lowers latency. It increases the emphasis on reliability and speed, and it can be of great use when you have to transfer large amounts of data between networks. Now, another way this can be useful is if it's used to add compute or storage capacity to data centers. Next, we have Azure DNS. Domain Name Service, or Azure DNS, can be used to host your domains on Azure. This provides high availability and great performance. It provides fast responses to DNS queries by taking advantage of Microsoft's global network. It also provides high availability. Next, we have Virtual Network. Azure Virtual Network allows the Azure resources to communicate with each other or other on-premise networks via the internet, and all of this is kept extremely secure. Now with this, users can create their own private network for communication. It provides users with an isolated and extremely secure environment for their applications to run. Now all of the traffic stays entirely within the Azure network, and it also allows users to design their own networks. Next, we have Traffic Manager. Now with Traffic Manager, you can route incoming traffic to improve your performance and availability. Now one thing it provides is multiple failover options. So if a particular situation goes wrong, there's always an option to consider to salvage the situation. It helps reduce application runtime and enables the distribution of user traffic across multiple locations. It also helps the people who are using it to know where the customers connecting from across the world. Next, we have Load Balancer. With this, you are provided the ability to instantly scale applications at the same time providing high availability and improved network performance for users' applications. It can be integrated into virtual machines and cloud services. It provides highly reliable applications. It also allows users to secure and integrate security groups. Finally, we have Azure VPN Gateway. Now this allows users to connect their on-premise networks to Azure using a site-to-site VPN. Now this allows users to connect their virtual machine to anywhere in the world through a point-to-site VPN. And also it's very easy to manage and is highly available. Now let's talk about the storage services. First, we have Data Lake Storage. Now with this, what you get is a scalable data storage with an emphasis on cost effectiveness and scalability. Now it comes of maximum use when you integrate it with other services so that you can get analytics on how the data is being used. It is also integrated with other services like the Azure Blob Storage. Now it is also optimized for big data analysis tools like Apache Spark and Hadoop. Next up, we have Blob Storage. Now Blob Storage provides a storage capacity for data. Now depending on how often a particular data is used, it is classified into different tiers. Now all the data that is within the Blob Storage is unstructured data. Now it has a way of ensuring that the data integrity is maintained every time a particular object is being changed or the data is being accessed. And it also helps improve app performance and reduces bandwidth consumption. Next, we have Queue Storage. Now with this, you have a message queuing system for large workloads. This allows users to build flexible applications and separate functions. Not to mention, with this, you can be sure that your individual components will not fail. It also makes sure that your application is scalable. Queue Storage provides queue monitoring, which helps ensure that the customer's demands are met. Then we have File Storage. Now with File Storage, you can perform file sharing with the help of the SMB protocol or the server message block protocol. Now this data is protected by SMB 3.0 and the HTTPS protocol. In this case, like we mentioned in functions, Azure takes care of all the hardware needs and the operating system deployments on its own. It also improves on-premises performance and other capabilities. Lastly, we have table storage. With table storage, you can deploy semi-structured datasets and a NoSQL key value store. Now this is used for creating applications which have a flexible data schema, and also considering how it has a very strong consistency model, it's mainly aimed for enterprises. Next, let's have a look at some web and mobile services. First, we have the Azure Search. Now with Azure Search, you get a cloud search service which is powered by artificial intelligence. With this, you can develop web applications as well as mobile applications. Now one big advantage is that you don't have to set up or manage your search indices. Azure takes care of that, and by extension, it increases your development speed. The artificial intelligence also will provide insights and structured information that you can use to improve the search and structured information. Next, we have Logic Apps. Now with this, you can create integration solutions which can connect applications that are important to your business. Now with this, you can visually create business processes and workflows. You can integrate SaaS or software as a service applications and enterprise applications. And more importantly, it allows you to unlock data within a firewall and securely connect to services. Next, we have web applications. Now with web apps, you can create, deploy, and scale web applications according to business requirements. Now it supports both Windows and Linux platforms, and it helps with continuous integration or deployment abilities. Another very important aspect of this is that the data can be deployed and hosted across multiple locations in the world. And finally, we have mobile apps. With mobile apps, you can create applications for iOS, Android, and Windows platforms. One advantage is that it automatically scales up and down based on your requirements. Now, in situations where you have network issues, offline data syncing ensures that your applications work anyway. And you can create cross-platform applications or native applications for iOS, Android, and Windows. Next, let's have a look at some container services. First, let's talk about ACS or Azure Container Services. It is also known as the Azure Kubernetes Services, as it's a fully managed Kubernetes container orchestration service. Now, what this means is that it eases the process of container integration and deployment. It also can be used with other resources from security like virtual networks, cryptographic keys, and so much more to ensure that your container is kept secure. Next, we have container instances. Now, this is similar to functions in a way, just that in this we're using containers without having to manage servers. Now, applications can be developed here without managing virtual machines or learning new tools. All that is Azure's problem to take care of. And it enables building applications without having to manage the infrastructure. That is, all you need to worry about is running the container. Next, let's have a look at some database services. First, we have the SQL database. Now with SQL database, what you get is a relational cloud database service. Now, this means that it helps accelerate your app development and makes it easier for you to maintain your application. Now, SQL database is also used extensively in migrating workloads to the cloud, and hence saves time and cost. It also helps improve your performance by integrating machine learning and adaptive technologies into your database. Next, we have Azure Cosmos DB. Now, this is a globally distributed multi-model database service. Now, what this means is that with this, you can create applications which support NoSQL. It provides a high-grade security system, has high availability and low latency. Now, this is usually used in situations where you have a diverse and highly unpredictable workload. Now, let's have a look at some security and identity services. Firstly, we have the Azure Active Directory. Now, if you want to know more about Azure Active Directory, I suggest you click on the top right corner and watch our video on the Azure Active Directory. This is just an introduction. So with this, you can manage user identities and you can make sure the resources are kept safe with the help of access policies. Most of these are intelligence driven. Now, one of the main features is that you can have access to your applications from any location or device. It helps increase your efficiency and helps down cutting costs when it comes to having a help desk. It can also help improve security and can respond to advanced threats in real time. Next, you have Azure Active Directory B2C. It helps provide customer identity and access management in the cloud. Now, protecting customer identity is extremely important for an organization, and that's what Azure AD B2C does. Now, it also enables the application to be scaled to great amounts, even billions of customers. Next, we have the Azure Security Center. This is basically like a command post with which you get a complete view of the security across users on your on-premises and cloud workloads. So with this, you are given a threat protection method that adapts to situations and helps reduce exposing you to threats. It also has rapid threat response and makes the process of finding and fixing vulnerabilities a whole lot easier. Next up, let's talk about monitoring and management services. So first, let's have a look at Azure Advisor. Now, Azure Advisor is basically a guide for the best practices when it comes to Azure. Now, when you follow these, it improves performance, security, cost, and increases availability. Now, it also learns from how you use the services on your configuration and usage pattern, and the adjustments that it suggests can be implemented very quickly and easily. Next, we have Network Watcher. Now, with this, you can monitor, diagnose, and understand the working of your network. Now, you can monitor your network without actually having to log in to your virtual machine. Now, you can also use something known as network security flow logs to understand the traffic pattern, how much traffic is coming towards you, how much you're giving, and so much more. It also helps diagnose VPN problems that you might have with detailed logs. And finally, you have the Azure Resource Manager. Now, with this, you can ensure that the resources that you have are managed and deployed at a consistent rate. Now, this makes it extremely easy for you to manage and visualize your resources that are used in your applications or some other requirements, and you can control who can access your resources as well as perform actions on it. And now, let's have a look at how we can use one of these services to satisfy a particular requirement. So the friend asks that she needs one last bit of help. She wants her friend's help to host a website on Azure, and here's how we can do it. So now we're going to put one of these services into action. So this is the Azure dashboard. So from here, we are going to create a virtual machine within which we are going to create a website. A very simple HTML website nonetheless. So let's get started. So first, what we're going to do is create a resource group. So what a resource group is actually a repository of all the resources like virtual machines or storage that you're going to use in your project. So in this, we need a virtual machine. So let's get that created. So first we'll name it demo East US and we'll create it. Now this will take a few seconds and that's it. So now that that's done, we go on add. So we're going to be using a Windows operating system. So we'll just search for virtual machine. We select this and create. Okay, so here we're going to we're going to select the resource group, the one that we just created, a virtual machine name. Okay, this storage and name. Passwords, and then just breeze through the rest of it. We can reduce the size, we don't need it this big. And create. Now that the validation is done, the next step is to create. Now this will take a few minutes, so we'll wait. And as you can see here, the virtual machine has been created. We'll go to resource. So here all we need to do is connect and download the RDP file. Let's see if we run this file and see what happens. Now this error shows up in a whole lot of systems that I've used. So there's a very easy way to troubleshoot this problem. So here's what you need to do. Now, so these are the problems. As remote access to the server is not enabled, the remote computer is turned off, the remote computer is not available on the network. So what we're going to do is go to networking and add an inbound port rule. Now we're trying to access a computer remotely, right? So to remotely access the computer, we would need to add an inbound port rule. So that's what we're going to do right now. So we can keep the source as any, port range as any, and our destination port as 3389. if you've noticed there, we'd actually have used the 3389 as the inbound port. And then we change the name as 3389 and this role is added. Now after this is done, all we need to do, you can see here that if you refresh the page, this would be here. A new rule has been added now, so we'll go to overview and try to connect again. Do the same thing again. And this time it worked. So here we'll input the name and our password. And that's it. Now we just press yes. And there you go. The system has started. Now your virtual machine is started. Now in a while, the server manager will pop up. So there's some things that we need to do so that we can host the website. So the first thing is to create an inbound port. So we'll turn off the virtual machine for now. Come back to that later. First we'll go to our resource group. Check the name of our resource. And then we'll look at all its resources here. So here we need to find the network security group and add an inbound security rule. Press add. We take any source port range, and then we add port 80, which is the one that we're going to use, and we'll put the name as port 80. We'll add the security rule. It will take a few seconds, and that's that. Now it's allowed. Now let's go back to our virtual machine. Here you go. And let's get it started. Log in again. And there you have it. It's on again. Now we'll go to Server Manager. So we need to add roles and features. So most of this we can just run through. We'll leave them at the default values. Same. And here we need to add a web server, which is the IIS. So we'll select this. We add the features. Next. So we can add the .NET 3.5 features as well. Next. And we'll install now. Now we'll wait for the installation to finish. And now the installation is done. So now what we're going to see is if the website can be reached. Now we'll go to the public address which is given here. So we've come back to our original system. Click. And you can see that the IIS page has been created. Now we need to work more to create the HTML page. Here's what we'll need to do to run our website. So right now what we're getting is this, the IIS page. Now let's make it our own HTML page, a very simple HTML page. From there on we can create the website. So go back to the virtual machine and then we go to C drive. So the IIS is located in a location which is in C drive, init pub and www root. So if you click on this, actually what you'll get is the page I showed you earlier, which is this one. So now we'll go to the server manager, click on tools and find the IIS manager. So we click on this and sites. Now there's a default website. We can now add a new one. The site name, demo. We need a physical path. We'll put it inside the folder we just saw, which is right here, C drive, init pub, www root, within which we'll create a new folder for Simplilearn demo. We save it and port 80 and okay. Now this is assigned to another site, so we'll change that, but we'll wait for that. Okay. Now for this, we'll just change it. We'll click on this. So since both of them have the same port, we'll change that. Go here, edit binding. We'll change this to something else. Okay, and close. So now both are different, and now we can start our website. It's already started now. Now we'll start the website. Right click this, so manage website, and start. And that's it. Now we will go to the init pub, www-root, and we have Simplilearn demo. So here we will create the HTML website, or the HTML, the document. So index.html. Okay, open this. It's a very simple website now, so we keep it, save it. So here what we're going to do is save as an HTML file, but for all files. We close this. Now to make sure this is recognized as a .html file, we'll go to view, options. Here we'll hide extensions for known file types. We'll just rename this. And there you have it. It's a .html file. Now let's go back to our original computer and run this page. And there you have it. Now this is just the initial version. More work has to be done on it, but your first step is already done.
And today we'll be talking about machine learning in Azure. Before we move on, let me tell you what Azure is. So Azure is Microsoft's public cloud computing platform. It provides you with various services like compute, analytics, networking, and storage. So you can pick from these services to develop and scale new applications or run existing applications in the public cloud. Okay, so once you log into your Azure portal and select machine learning as your service, you'll be redirected to this page. Now on the right hand side, you can see there's an option called My Workspace. So once you click on My Workspace, it will take you to a new window, which is Machine Learning Studio. But before that, let me give you a small idea of what My Workspace is. So any data that we get into our Machine Learning Studio, we analyze it, and that is presented under My Workspace. Now on the left hand side, you can see there are a few options under Machine Learning Studio page. So let me go through those options one. So the first option is projects. So project basically gives you a list of all the experiments that we have worked on. Then comes experiments. So experiments are all the programs that you work on to create a model. After that, it's web services. So since Azure is a cloud computing platform, we know that all the data needs to be uploaded over the cloud. By data, I mean all the experiments that we have needs to be uploaded over the cloud. So web services gives you a list of all the experiments that we have and is over the cloud so that you can access it from anywhere. Then comes notebooks. So notebooks are basically space where you can explore analytics, you can create your own code, you can visualize it, and at the last you can share it with your peers. Then is datasets. So the dataset gives you a list of all the datasets that you have in your Azure portal. Now when you click on sample, these are all the sample datasets that Azure has provided as to the users. Now comes train models. So while working in an experiment, you'll come to a point where you need to train your model. So this gives you a list of all the models that you have trained in your Azure program. Then at the last you have settings. So any changes that you make is done under settings. So now that we are done with this, let's go to the next half of our Azure tutorial. So on the left hand side, you can see there's an option called new. When you click on new, it will open a window. So this window gives you a list of all the templates that we have in our Azure Machine Learning Studio. Okay, so since we are working from the scratch, we'll be working on blank experiment. So once you click on blank experiment, a new window appears. Okay, so let me go through the components that we have here. So on the left hand side, you have the components. At the center, you have the canvas where your experiments will take place. And on the right hand side, you have properties. So today we'll be working on problem statement, which says that we need to find out the income of an individual whose data we don't have in a system. Now let's go on to the component part and find the best data set that can suit our problem statement. Okay, so we see that we have list of data sets in our samples. So the very first data set is adult census income binary classification. So we'll select the data set and drag it over to the canvas. But before that, let me give a name to our experiment. So we'll give the name as income prediction. Now once you click on adult census income, you can see there is a circle. Press right click and 4 options appears in front of you. The first one is download, the second is visualize, third is generate access code, and the last one is notebook. Since we need to visualize the data set, we'll click on visualize. So once you click on visualize, a new window appears. On the left hand side, you can see there are 32,000 rows and 15 columns that we have in our data set. But before that, let me go through all the columns that we have here. So the first one is age, which tells you about the age of a person. Then is work class. So this gives you an idea whether he's a government employee, is he working in a private sector, or is he a self-employed. Then is FNL WGT, which is the sample weight of the field. Then is the education. So education is basically telling us about his highest degree, whether is it bachelor's, is it high school grad, or is he a master's. Then comes education number. So this gives you an idea of the number of years he took to complete his education. Then is marital status. So this is telling about a person's, is he married or whether he has never married. Then is occupation. So occupation is actually important while finding out the income. So if a person is a manager, there are chances he will be earning more as compared to others. Then is relationship, whether he is a husband, is she a wife, or has he never married. Then comes sex, whether he's a male or the female. Then is capital gain, capital loss, hours per week. So this gives you an idea of number of hours a person is working in a week. Then is native country. So income varies from country to country. So getting to know about the country is also very important while predicting our model. And at the last, we have income. We see that the income column is divided into 2 halves, which is above 50 and below 50. So there are 2 distinct values in income group, and in cases like these, we make use of classification algorithm. Now let's go to the next part, which is where we will define the fields that we need to have for our prediction. So what we do here is we select the column. So on the search bar, when you type column under manipulation, you get a list of options. From that, you select column in dataset and drag it over to the canvas. Now connect your dataset with select column in dataset. Now under this, you can see there's a caution which says that value required. So you go under properties and select launch column selector. So once you select launch column selector, window appears. So this gives you a list of all the columns that we have in a data set. So the very first column that we have here is age. So age is actually important in understanding the income of a person. Then comes work class. So the background of a person, whether he's working in a government employee or is he a private employee, is also important for prediction of income. Then comes education. A person who has a master degree has more chances of earning than a person who has a graduation degree. So education is also an important field while predicting our income. Then what comes next is occupation. After that you have country, and at the last we'll work on income. Now when you press next, you get back to the same window. So now that we know the fields that we're working on, our next step is to find the algorithm that best suits our model. Okay, so now that we know the fields that we have to work on, our next step is to find the best fit algorithm for our model. So what we do here is we look at the list of algorithms that we have. But before that, we know that our target value is divided into 2 classes. So the algorithm that we'll be working on is a classification algorithm. Now Azure provides few classification algorithm like logistic and decision tree, 2-class boosted decision tree. So we'll be working on 2-class boosted decision tree because this gives you a high accuracy rate. Now let me give you an idea of why 2-class boosted decision tree is taken over all the other classification algorithm. So what happens in 2-class boosted decision tree is for every node that we have here, the accuracy is calculated. And once the accuracy is above our required accuracy, then only it moves on to the next nodes. So this gives you a high, so the prediction value here becomes more and more towards a higher side, so that the overall model will give us a very high accuracy. Okay, so our next step here is to train the model. So on the search bar again, just type train, and under train you can see there's an option called train model. So drag the train model over the canvas and connect the 2-class boosted decision tree with this. Now you can see that it says that it requires a value or data, which is obvious because it does not have any data to work on. So our next step here is to split the data. So on the search bar, when you find split, it gives you an option called split data. When you drag the split data over a canvas and connect it with your column data, it asks you for the split percentage. So you split the data into training and testing. So 80% of data gets into the training model and 20% goes into the testing model. So what we do next is we connect 80% of training data with the trained model. But you see there's a value required. This is because the model is not aware of the column it needs to train on. So what we do here is we go on launch column selector and select the column. So we need to work on income column. So when we select column and press enter, we see that the question mark is gone. Now our next step is to find the score of the model. So what score does is it gives you the prediction value of the model. Okay, so when you connect your trained model with the score model, you again see a caution sign here. This is because it does not have idea of what it needs to test on. So you connect your testing data with your score model. So our last step here is to evaluate the model. So on the search bar, when you type evaluate, you get an option called evaluate model. You drag the model here on the canvas and connect it with the score model. So your model is now complete. Now our next step is to save the model and run it. Now once our program is executed, click on evaluate model. Once you click on evaluate model and press visualize, a window will appear. This shows you the performance of the model. You see that the accuracy is 79, which is considered to be good. Now let me go through all the other options. You see there is an option called positive label and negative label, which has been assigned values of above 50k and below 50k respectively. Now let me tell you what these values are. So this part is known as the confusion matrix. So of all the values above 50k, true positive give me value that are predicted correctly and false positive give me value that are not predicted correctly, which means that 6 out of all the value that we have in positive label, 667 have been predicted right. That is, they have their salary above 50k and 422 have been predicted wrong. Similarly, there out of all the people that we have, 840 have been predicted wrongly. That is, they have salary of above 50k but have been predicted below 50k, and 4091 have been predicted correctly. Now this is used to find the accuracy of the model. So what you do here is you sum the true positive with true negative and divide it by false positive, false negative, true positive and true negative, and then you multiply it by 100, and that's how you get your accuracy. Now let us go back and run this service over the net. So when you click on set a web service, you see predictive experiments. Click on predictive experiment. Now our next step is to connect a web service input, that is the entry point, with the score model. So what it does is once the program is over the cloud, it directly connects to the score model and shows us the output. So you don't have to go through all the processes now because the machine is automatically learning. Now you save this and press run. This will execute the entire model. So once this is done, all that is left with you is to deploy web service. So once you click on deploy web service, it will take you to the dashboard. So you see an option called test. Once you click on test, it will take you to a window where it will ask you for values. So let's just say that I have a value of person age 35. Let's say he's working in a government. His education is bachelor's. Then his occupation is manager. His country is US. So once I press next, it will give me the predicted value telling me that he will be earning 50k with a precision rate of 0.12. So this is how you make use of machine learning in Azure.
We are going to talk about the service Azure Active Directory. So firstly, let's ask the most important question. What is Azure Active Directory? Now, here we are in a situation where we have two colleagues having a conversation with each other. So one of them complains that he is finding a hard time managing multiple user logins at the same time. His friend suggests that he has a solution, that the company start using Azure Active Directory. He says that with Azure AD, they'll be able to handle multiple user logins without any issue. So just like the question in all our minds, the friend asks, how is Azure Active Directory going to help us? So to help you understand, let's think about a scenario. Now you're an employee working for an organization and you want to use a particular service, in this case SQL database. So you're assigned a set of username and password. Then you want to use another service, a machine learning service. Again, you're assigned a different username and password. And likewise for any number of services that you want to use. So for every service that you're going to choose, you need to be assigned a new username and password. But this becomes a huge issue for the administrator as they have to handle a large number of username and passwords. Now, if you think about a large organization where there's more than 1,000 people working, you can understand how much of a hassle it's going to be for the administrator. At the same time, it's also a really difficult thing for you to remember that many numbers of username and passwords. It's difficult on the user as well. And that's where Azure Active Directory helps. Now, here's a scenario where we're applying Azure Active Directory. Now, you're an employee, you want to use a particular service, and you're assigned a single username and password. And with this username and password, you can access all the services that you want. So there's only one set of username and passwords that you need to remember. You can use any of the services that you want as long as the administrator has given you access to it. So what is Azure Active Directory? Now, Azure Active Directory is a service that falls under the identity domain. It allows multiple users and is a cloud-based directory and identity management service. Now, here's an ideal scenario. You're joining an office newly. The admin helps you sign up to whatever services you want, and you can access these services anywhere over the cloud. So now let's talk about something different, Windows AD and Azure AD. Now, Windows AD was the previous version of Azure AD. So now we'll talk about why we needed to change from Windows Active Directory to Azure Active Directory. So what is Windows Active Directory? Now, it's an OS directory service which allows you to work with multiple systems, multiple network resources in a unified manner. Now, the biggest draw when it came to Windows AD was that it had many layers. Now, different layers that did different bits of work. So now let's talk about each of these layers. The first layer is ADDS, or the Windows Active Directory Domain Services. Now, each layer, as I said before, has a different role to perform. ADDS allows admin to manage information relating to user logins and other details like when they signed up, how much they're using, and things like that. The next layer is ADLS, or the Azure Data Lake Storage Services. This layer is for allowing you to store any amounts of data of any type or size. Then you have the ADFS, or the Active Directory Federation Services, where you're given a single option for sign up with which you get access to all systems and applications. Then we have the fourth layer, the ADCS, or the Active Directory and Certification Services. This enables administrators to customize services and then be able to manage and issue public certificates. And the final layer is ADRMS, or the Active Directory Rights Management Service. And this is used for data protection. Now, here's where Azure Active Directory changed the whole game. This means that there's a large number of layers that administrators need to take care of. Now, how about there was a solution for this? And Azure AD is that solution. Azure Active Directory integrates all these 5 layers into 2. And these are the Windows Azure Active Directory, or the WAAD, where it combines all the problems when it comes to identification management, which is almost all 5 layers taken into one. And the Windows Azure Access Control Service enables the federation or the division of all these services of an organization. And by division, I mean assigning each of these services to these users. So that is taken care of by the Windows Azure Access Control Service. Hence, Azure Active Directory is able to simplify a lot of the problems that Windows Azure Active Directory had. For example, the application Office 365 uses Azure Active Directory to manage user identities. Here's how. Now, you're an employee who wants to access one of the Office 365 services, which could be Excel, PowerPoint, Microsoft Word, or something like that. So you go talk to the administrator and he gives you access to these services with the help of a single username and password. Now, as long as you have this username and password and the administrator has given you access to it, you can use any of these services. So who's the service audience? Who is using the Active Directory service? Now, there are 3 types of audience when it comes to Azure Active Directory. The first one is IT administrator, the second one application developers, and online customers. So the IT administrators, their main emphasis is to ensure that the sign-in takes place. They take care of all the sign-in procedures. They also solve issues when it comes to authentication. For example, to authenticate a particular user, the problem is solved by the IT administrators. Then you have application developers who use these services to develop applications. And with this, they have an easier time developing applications as all these resources are easily available. You have online customers who make use of services like Office 365 and other CRM services and have all their demands catered immediately. So now let's have a look at how we can use Azure Active Directory to provide access to a particular individual. So if you log into the Azure account, this is what you see, or you go into Active Directory, a list of all the people who are using or have been given permission to use resources from Azure. Okay, now we're going to create a profile. We need to set up his name, which is John, and second name, Jacob. Now for properties, we need to determine the source of authority, which is already the Active Directory, so that's fine. We can select a group or add them to a particular group if we feel like it. Now, if we add them to a particular group, it means that they have access to all the resources that everyone in the group has access to earlier. So we'll do that later. We'll select their directory role, or we can select it here if we need to. It could be user, administrator, or a limited administrator. And now we'll set up a password. So we already got one, and we'll create. And that's it. We have created a user. Now we'll go to their profile. So what we can see here is that you have access to every bit of detail related to this account. So you have the name, your first name, the username, the object ID, job info, everything. You can even have other details like how often they've signed in, when did they sign up. You can check their password, you can reset the password, delete their account, and so much more. Now we can even add a directory role, which we saw earlier. And now let's add this person to the admin group. So, he gets access to all the services that those people have access to. And select. That's it. We've added them. Now the other things that you can see here, there are applications, licenses, devices. These are all restrictions you can add or remove, like which device you can use the system through or with and stuff like that. So that's it. And with that, we've created a user and given him access to certain services. We're going to talk about another important Azure service, Azure Data Factory. Now, why should you be interested in Data Factory? Now let's consider a scenario. So here we have two colleagues having a conversation with each other, and they say that the data that they're generating from their applications or products is increasing exponentially. Now, considering that this data is coming from a number of different products, it'll be a bit of a task to analyze and store all of this data. So he wonders how they're going to manage that. His friend suggests that they use Azure's Data Factory. Now, what does Azure's Data Factory actually do? First, it stores data with the help of the data lake storage. Now, any kind of data can be stored in the data lake storage. Then you can analyze the data, you can transform the data with the help of pipelines, and you can publish the organized data. You can visualize the data with third-party applications like Apache Spark or Hadoop as well. Now, what exactly is Data Factory? So now let's have a look at what exactly is Data Factory. Now, Data Factory falls under the identity domain of services in the Azure catalog and is a cloud-based integration service. Basically, what it does is it works on your data, it stores your data, it orchestrates and automates the movement or transformation of data. It works heavily on the data that you store. Now, let's see how it actually works or how the flow of its processes are. Firstly, we have the input data set, which is nothing but the data that you have within your data store, the one that you need processed. Then you pass this data through a pipeline. Now, what does a pipeline do? A pipeline basically performs an operation on the data that transforms it, which could be anything from just data movement or some data transformation. Now, data transformation is possible with the help of USQL, some stored procedures, or Hive. Now, after this is done, you get an output dataset. Now, this output dataset will contain data that is in a structured form because it's already been transformed and made structured in the pipeline stage. Then it is given into linked services like Azure Data Lake, block storage, or SQL. Now, what it does is these store information that is very important when it comes to connecting to an external source. Now, this is, if you wanted an example, how in an SQL server you need to mention the source and destination of your data. Now, for example, consider an SQL server. So you need a connection string so that you can connect to an external device. You need to mention the source and the destination of your data. This is how the link services work. And finally, you need a gateway. Now, a gateway basically connects your on-premises data to the cloud. So you do need a client installed on your on-premises system so that you can connect to the Azure cloud. And finally, you have the cloud. Here what happens is your data can be analyzed or visualized with a number of different analytical softwares like Apache Spark, R, Hadoop, and so on. So all this time I've been mentioning that data lake is a very important part when it comes to Azure Data Factory's proper functioning. So now let's talk about what exactly is data lake. Now data lake is a data storage or a file system which is highly scalable and distributed. It is located in the cloud and works with multiple analytics frameworks, which is external frameworks like Hadoop, Apache, and so on. So now let's have a look at it. So first you have your output data set, which is data from the mobile, video, web, social media, so much more. It is sent into the Azure Data Lake store, and then it is provided to external frameworks like R, Apache, and Spark so that they can be worked on. Now, there are two main concepts when it comes to data lake storage. So one of them is storage and the other one is analytics. Now, storage is of unlimited size. It can be petabytes, terabytes, gigabytes, and so much more. It stores a wide variety of data. It could be unstructured or structured data, and it can store really large files. And another concept when it comes to data lake is analytics. Now, how it works. Now, here are two examples of how analytics works when it comes to data lake. Now, when it comes to analytics, you can monitor and diagnose real-time data. For example, data that you're getting from vehicles or buildings. These can be used to optimize how they work, respond to certain events, or generate alerts in case something goes wrong. Then you can also identify fraudulent transactions on your credit card, or you can identify the geographical position of your card. Perhaps monitor how many transactions have been taking place on that card, and so on. So now we're going to have a look at how we can use the Azure Data Factory to move data from an SQL database to a blob storage on the cloud. So here's what we're going to do. So first off, to make a database, what you're going to need is software known as SSMS. So you can find it on Google. It's called, you just need to Google it, SSMS. The first link you can take here, and there you have it. So you just need to click here and download the file. So I've already downloaded the file. So basically this is used to create a database which we'll be transferring to the blob storage. So this will take about, depending on your computer speed, pretty long or little to no time. I've already downloaded it. The process is very simple. Just directly go on saying yes, yes. And finally, once the installation is done, here's what we're going to do. We should go into the dashboard of Microsoft Azure. We need to create a data warehouse. So we'll go into all resources, create resource, go to database, and select SQL data warehouse. There we have it. Now, it's very important that you remember the names of the service of everything that you're going to write here, because each of these become very important later on. So I've already set up a possible set of names. YouTube, it's free trial. The resource is already created. A blank database. The server, we need to create a new one. So we'll name it as YouTube server. YouTube admin as the server admin login. The password as alright, the location does not matter. Okay, that's done. Now here the server is done, and here we need to change how much you want the lowest, how much computation you want, how much the workload, how important your workload is. So we'll put it at the lowest since we don't require much. We'll apply. The rest is normal and create. So now we're creating an SQL data warehouse. So we'll wait. So now the deployment is done. So we'll go to the notification and go to the resource. Here, now this is done. So we'll go to the SSMS, which I've already opened here, and then go here and copy this. Paste it here. SQL authentication, login, which details we have already stored here, which is admin, YouTube admin, and the password, which is also given there. Right. Go to options. We go to the database name, which is YouTube. Everything else is there. We need to change it to TCP/IP and connect. We sign in. We'll add the password. Again, we're going to sign in now. Right. So now that that's completed, you can see that this is what will pop up. So this is the name of the server we've given, as you saw earlier. We go to databases, and here you have the YouTube database that we just created. Right click this and add a new query. I already have a code for this program. It's a very simple program, so copying and pasting this. Now, if you need the code for this program, let us know in the comments below. It's very simple. What we're doing is creating a table called demo tab with first name Clark Kent and last name is Bruce Wayne. And the table that's created will have these 2 rows. So now we're going to execute this. There you have it. 2 rows have been affected. So now let's have a look at our table. Execute this line. And there you go. The table's here. So now that this is done, we're going back into Azure. And we need to create a storage account. So that's where the blob storage is going to happen. So we're going to storage accounts and click on add. So here it's a free trial. Resource group is YouTube. Storage account name is Simply Store. That's all. Okay. US performance is standard. General purpose can do locally since we don't need it to be very reliable, at least for this one. Advanced is fine. View and create. That's done and we create. Now we'll wait for the deployment to finish. And that's it. The deployment is done. So we'll go to the resource and go to blobs. So this is where the storage is happening. We need to create a blob. Simply blob. Which does not exist. And okay. It has been created. Now for the next bit, we need to create the data factory now. So we go to all services, search for data factory. We press add. So here we'll free trial, use existing, which we have YouTube, East US and create. So now we've created a new data factory. Now we'll wait while it's being deployed. So now it's created. So we'll go here and here we click on copy data and this opens up. We'll name it. Now description, run once now. Okay. Right, so we press next. So we need to connect to a data source. So what you need to do is select Azure SQL data warehouse. So one second, go to previous. Here we select Azure SQL data warehouse. Go here, search for source, Azure subscription, free trial, here YouTube server, and the database is YouTube. You also need to provide your username and password. I've saved it here. YouTube admin. Right. Okay, now we can select the table, which is demo tab. Next. And now for our destination. So where are we going to connect this to? We're going to Azure Blob Storage. Next. Destination. Azure subscription free trial and Simply Store. Now we need to name our storage path. Next. All of this can be passed on. So here's what we're doing. We're copying whatever is inside this to the Azure Blob Storage. That's what's happening right now. All of that is set and next. It's validating and we'll wait now. It's registering connections, creating database, and in the end it's creating a pipeline. So you can monitor the pipeline from here if you feel like it. Now, here's what we're going to find. So here's a visual representation of what's happening. It's being copied into the blob storage. Now let's have a look if it's actually worked out. We go to our database. We'll go into storage accounts, Simply Store. Go to blobs. We've created a new one. And there you have it. So based on the container that you've named there, it's created a new one here. So actually I had earlier created the name called Simply Blob. But as you can see here, as long as you name a container, it will create a folder inside which you will find your particular thing that you copied. And that's it. You've copied data. Similarly, you can do a number of multiple operations on this container, on the pipeline you just created with the data factory. And that's that.
Today, we are going to learn about the Azure Virtual Machine. So, without further ado, let's get started. Before getting in depth, let me tell you what's in store for today. First, I'll be talking a little about Azure. Next, I'll start off by explaining the Azure Virtual Machine. Then, I'll be focusing on few benefits of Azure Virtual Machine. Moving forward, I'll be going in depth with the Azure Virtual Machine components. And finally, we will be looking into a demo on Azure Virtual Machine. All of us may have heard of Azure at one point of time, but what is Azure? Let me explain. Azure is a cloud service created by Microsoft for building, testing, and managing applications and many services through the Microsoft data centers. The Azure hosts web applications over the internet with the help of these data centers. Azure is very flexible. It gives an option to have the functionality as required. You can pay as you consume, switch to Azure, and accommodate the business fluctuations. There is no need to worry about the infrastructure all the time. Azure is very reliable and has 24/7 tech support. Azure offers pay-as-you-go pricing and hence it is very cost-effective. Staying online all the time ensures customers or users trust. Azure supports backup and disaster recovery tools. Now we know what Azure is and its key benefits. Let's now move on to Azure Virtual Machine. Before that, let's consider a scenario. Rachel had to host 10 virtual machines at once for a project. There was an issue when her computer RAM was not compatible with the instances. The computer RAM was only 8 GB and the instances that required were 10 GB. Then she says, I wish there is a service that's cost effective and also provides extra RAM memory. One of her colleagues heard this and he comes up with an idea. He says, can we use Azure Virtual Machine? It has a pay-as-you-go pricing and has disks for storage. You can pay for what you use and create any number of instances with high storage capacity. Also, if any technical difficulty arises, you can easily retrieve the files through the backup server. So now she's happy and she wants to know more about Azure Virtual Machine. Azure Virtual Machine is one of the wide range of services that Azure offers to create your instance. A virtual machine is a computer file, typically called an image, which behaves like an actual computer. It runs in a window, giving the user the same experience on a virtual machine as they have on the host operating system itself. Multiple virtual machines can run simultaneously on the same physical computer. Each virtual machine provides its own hardware, like CPUs, memories, and other devices. Azure Virtual Machine offers a high range of flexibility and it maintains the physical hardware that runs on it. Let me explain some of the benefits of Azure Virtual Machine. First, we have easy development and test. Azure Virtual Machine has a quick and easy way to configure the computer that is required to code and test an application. Next, agility and scale. Azure Virtual Machine is agile and the ability to clone and spin up multiple instances of the same virtual machine allows us to scale services and applications rapidly, efficiently, and very cost effectively. Azure Virtual Machine provides enhanced performance. Demands for applications can fluctuate, so you pay for the virtual machines you need and shut down the unnecessary ones to save the cost. Azure Virtual Machines provide extended data center and can be easily connected to an organization's network. It is easy to set up your redundant infrastructure on Azure, and Azure provides a full disaster recovery site at a fraction of the cost. Furthermore, let me explain Azure Virtual Machine components in details. Virtual Machine comes under the compute domain of Azure. It also offers various services like availability sets, snapshots, disks, images, and many other services like hosts. Virtual Machine can be clubbed with other services like disks, images, availability sets, hosts, and many more. So, the first component and the most important component is the operating system. The operating system creates connections to the remote desktop session host. There are many operating systems available like Ubuntu, Red Hat, Linux, Windows Server, CentOS. You can also set the operating disk size so that the memory is not wasted. The next component is disks. Azure Virtual Machines use attached virtual hard disks for storage. There are two types of virtual hard disks. First is an image. It is a template for creation of new Azure Virtual Machine. Then we have disks. It is a bootable virtual hard disk. All durable disks are backed up by page blobs in Azure storage. Therefore, the disks inherit the benefits of blob storage, high availability, durability, and many more. The disks are mounted as drives on the VM. The next component is virtual network. Many components operate the virtual machines in a scalable and secure manner. Virtual networks could include equipment such as separate network spaces for internet-facing and backend servers, load balancers, firewalls, and more. Many of these components are deployed into an Azure Virtual Network. Azure Virtual Network provides many features such as subnet, IP address, load balancer, and network security group. Another important component of Azure Virtual Machine is availability sets. If in case there's a slight chance there could be a failure in physical servers, then these come into picture. So in case of such failure, the Azure platform will migrate the failed virtual machine to a healthy host to reconstitute the VM. It is highly recommended to deploy at least 2 instances of the virtual machine, and virtual machines placed on an availability set perform identical set of functionalities. Now that we know what Azure Virtual Machine is, let's look into the demo. In this demo, first we are going to create a virtual machine, connect it, and then create a web server and modify the web server, and finally launch the web application. So let's go ahead into the demo now. So the first step is to log into Microsoft Azure with your credentials. Now let's click on virtual machines and create a new one. So I can put add. And you can use the subscription you want, either pay-as-you-go pricing or free tier. Resource group will create a new one, that is payroll 1. Okay. Virtual machine we can create, I'm going to use VM web 001. And then region I'll be using East US. Then image I'll be using Windows Server R2 data center. Size I'll be using B1MS. Select username root admin, and then password of your choice. And then I'm going to allow selected ports and choose RDP 3389 and next. So OS step I'll be using standard HDD, and then next. So I can see a default virtual network and a default subnet and public IP as well as default. Then next. You can allow for auto shutdown, but again, it's entirely your choice. I'm going to select an extension to install, and I'm going to install Microsoft Anti-Malware. Create, okay. I'm going to create a few tags now. Let's go ahead with it. So I've created 5 tags. Now review plus create. Okay, so everything seems good. Let's create now. So the deployment is going to take a few minutes. Let's wait for it. Okay, so that's done. Now let's go to virtual machine and see our virtual machine. Okay, so it's been deployed. Now let's get into the virtual machine and copy the IP address. Then hit Windows plus R and open MSTSC and paste the IP address and connect. Let's use a different account. You have to use the administrator account that we created before with the same password. Click OK. Now the remote desktop session host opens. The next step is to click on Server Manager and add rules and features. Click on Next. select role-based or feature-based installation and click on next. Then select the virtual machine you've created and next. And then we are going to select web server IIS, next. Next. Okay, so it's already installed on my computer, but you have to install this. Then let's close this and open Internet Explorer. Let's type in HTTP localhost. Yeah, so now we can see the default browser opening. Let's minimize this and let's try it here. Here you have to just put the IP address. I think there's an issue. Okay, so let's add an inbound port. Networking, select networking and add inbound port. Let's name it port 80 and add okay, so it's added. Now let's go and refresh it. Now we can see the default web browser opening. So the next step is to modify the web browser. Let's go ahead with that. Go back to your remote session host. Let's go to File Explorer. So certain folders are created in the C drive. Let's open that. It would be under inetpub. So this is where the default browser is coming from. Now let's make a new text document. Open that and put hello, welcome to this demo by Simplilearn. Save it, close it. Let's rename this as index.html. So this is a text document, so we need to change that. Okay, let's remove this. Okay, that's done. Now let's go back to our Internet Explorer and hit F5. Let's refresh this. Let's try now. Okay, so let's so it's done. Now let's go back to the previous browser and try. Let's refresh. Yeah, that's done.
Hi guys, a very warm welcome. So today's topic is Azure Virtual Network tutorial. Let's look into what's in it for you. So we would be covering why is Azure Virtual Network important, what is Azure Virtual Network is, benefits of using the Azure Virtual Network, components of Azure Virtual Network that includes the subnet, routing, network security group, why these components are required to be created in the virtual network, and how to launch an instance within the Azure VNet or the virtual network. And then we will be seeing one demo in which we'll create Azure Virtual Network subnets and network security groups. So first of all, let's look into why is Azure Virtual Network important. So why Azure Virtual Network is required? So somewhere far away at an office, a company was struggling with few challenges. The company got a bigger projects which lead to the following challenges. That includes poor network connectivity, time-consuming process in building network topologies, could not divert network traffic to its destination on time. So these were a couple of challenges the company was facing. So the employees thought that what could be the possible solution to these challenges? And then we require the Azure Virtual Network in that case. So first of all, let's understand what is Azure Virtual Network is. An Azure VNet or a virtual network represents your network or environment to run VMS and applications in the cloud. When it is created, the services and virtual machines within the network interact securely with each over the internet. So virtual network, you can consider it as a virtual cloud, which is basically kind of a cloud space virtually assigned to the users or to the organization, which they can dedicatedly use for their purpose. So for example, if you have to create some instances or virtual machines onto the Azure cloud, and you want to connect it with the on-prem servers, for example, then you might require the virtual network in that case. Let's assume that those instances that are created in the virtual network require the range of IP addresses that you want to allocate to them, and that is something you can customize using the Azure Virtual Network. How do you want that the traffic should be routed to your instances in the virtual network, how the firewall securities should be applied? Everything the end user can control in the virtual network. So it seems like that you are working in your own data center. Ideally, you would be working onto the Azure cloud using the virtual network. Now, what are the advantages of using the Azure Virtual Network? So a couple of them are, it provides an isolated environment for your application. So as I said that, it seems like that you are working in your on-prem environment. That means within your data center. But ideally, it is a virtual space that is allocated to you, which is a kind of an isolated environment that is specifically designed for your task and the activities. Generally, a subnet in a VNet can access the public internet by default. So we create a subnet inside the virtual network which can access the public internet. So there is a public network connectivity that is enabled in the virtual net so that a subnet which will be created in the VNet can be accessed. Traffic can be easily filtered from different resources. So you can have some control lists defined, you can have some security groups created, and how do you want to allow the traffic onto the servers or the application? That is something which you can control. It is a highly secure network, and the security groups and the policies are basically implemented by the end user. So you can design how the security should be implemented. High network connectivity, so you have a higher bandwidth as compared to the normal internet connection you might be having in the data center. Compared to that, you use the Azure network only, which gives you the higher network connectivity. It builds sophisticated network topologies in a simple manner and which is easily manageable, as well as there are less troubleshooting issues that we would encounter. Now, what are the components of Azure Virtual Network? One of them is the subnets. Then you have routing. Then you have network security groups. Now, what do we mean by subnets? The subnet is one of the major or a prime important component in the virtual network. So what you have to do is, first obviously you would be creating a virtual network. Inside that you can create the subnets. Subnets, you can consider it a logical partitioning or virtual partitioning inside the virtual network. Subnet lets user segment the virtual network into one or more subnetworks. For example, let's assume that you're working in an organization, and in the organization there are different departments. For every department there should be some set of IP addresses that you want to allocate to the machines that the employees are using, or all the departments should be isolated. That means that they should have their own network IDs and the network addresses allocated to their machines. And in that case, what you would do is you would create the subnets and the subnet IDs that would be allocated to those departments. These subnetworks can be separated logically, and each subnet consists of a server. So what you do is, when you create a subnet, you can create a server or an instance inside that subnet, and how do you want to give an access to that instance depends on criteria or the requirement. hence a subnet can further be divided into two parts, one as the public subnet and the other one as the private subnet. These are the naming conventions of the subnet. Then how do you want to give the internet connectivity depends on how the public subnet should be interacting with the internet. And for the private subnet, as the name suggests, that the internet is blocked. So that means it is completely isolated in the virtual network. The private instances, though, if you want that any instance created in the private subnet should have the internet connectivity or an access, you can primarily go with the NAT gateways in that case, which is a network address translation or kind of a translator which converts the private to public and vice versa. And that would actually enable the internet connectivity to your subnets. Then in the public instances, they can directly access the instance. As the name suggests, public instances, that public subnets, that means they have the direct internet connectivity. Next component is routing, and the routing is primarily a routing rules, you can say, that are applied, and those are actually applied to the routers only. So since on the cloud we cannot have a direct router access, and hence using the routing as a component, we can define some routing rules which are directly applied to the router in the infrastructure. It delivers the data by choosing a suitable path from source to destination. For each subnet, Azure Virtual Network automatically routes traffic and creates a route table. When you create a virtual network, automatically a route table is created, and that basically is required to route the traffic, and that can be used by every subnet. That doesn't mean that you only have to create a single route table in the virtual network. You can have multiple route tables also created, which can be associated with different subnets as well. Then you have the network security groups. It is kind of a firewall that protects the virtual machine by limiting the network traffic. It restricts inbound and outbound network traffic depending upon the destination IP address port and the protocol. So it is basically the network security group sits on the instances and or virtual machines, and they basically define that how the traffic should be reaching to the ports onto the virtual machine. So how do you want to open up the ports, and for which IP addresses you want to open up the ports? That is something the end user or the administrator has to specify or design. So they act as a kind of a firewall rules only that protects the virtual machines. So how to launch an instance using Azure VNet? So first of all, you have to create a virtual network. So virtual network act as a container for subnets. So first thing is that you would be creating a virtual network. Then you would be creating subnets which are considered as a subset within the virtual network. So cloud instances included in the subnet. So first VNets are created, then the subnets are created, and then you configure the properties in the security group. Have a look at this in detail. Now, with respect to the virtual network, what you need to do is you have to create a virtual network in the Azure cloud. Then you have to create subnets into each virtual network, which is kind of a subset of a virtual network. So you can create one as a public subnet, the other one as a private subnet, for example. Now you have to assign instances. So when you create an instance, you have to specify that what is the virtual network, for which virtual network you are creating an instance. Within that virtual network, you have to select that on which particular subnet the instance should be created, and then connect instance to a relevant network security group. So attach your network security group to the instances, and based on the properties or the rules that are defined in the network security group, that will be applied to the instances within the subnets. Finally, configure the properties in the network security and set the policies. As a result, you will be able to launch your instance on Azure within the virtual network. Now we will be seeing one demo that how we can create Azure Virtual Network subnets and the network security group. So just be there to watch our demo on the Azure Virtual Network. In today's session, I would be showing how you can create the virtual networks onto the Azure. And for that, you require the credentials on Microsoft Azure, and here you can see on my screen that I have already logged into the Azure console. Now what you need to do is, in order to search virtual network, you can type and search in the dashboard, in the search bar, with respect to the virtual networks. And here you can find the virtual network and the gateways. So what you need to do is you just have to click on the virtual networks, and then it will give you the options to add the components inside the virtual networks. So let me first open up the virtual network. Right. Now, in theory, we discussed that the virtual network comprises of multiple components and subcomponents. So primarily is that first you have to create a virtual network. Then you have to assign the IPv4 CIDR block to the virtual network. And then you create the subnets inside the network, which is a subset of the virtual network. Along with that, you define the routing rules. And likewise, you create the instances inside the subnets that will be part of the virtual networks. So that's what we are going to do in this demo. So I would be adding up a new virtual network. So you can see here there are already two virtual networks that have been added. One is the demo VNet, which is by default. So when you created the Azure credentials, the demo virtual network was already created by the Azure so that it can provide you the default settings. And then the test one has been created by me, and that's the customized one, or you can say a non-default virtual network. So I'm going to add another VNet and would define the name to it. So let's wait for the details to appear. So here you have to define the virtual network to create. Obviously we will be going with the free trial only. And then you have to create a resource group. So what is a resource group? It is primarily a collection of resources that share the same lifecycle, permissions, and the policies. So if you have a resource group created, you can use it. Otherwise, you can create a new resource group. So I already have one, that is the demo one. I would be using that. In the instance details, you have to specify the name of the virtual network. So these are certain parameters that you have to go with while defining the name. So let's say I put something like test VNet as the virtual network that I want to create, and that is you have to select a region where you want to get that created. So these are the available regions that you can select. I would go with US East US only, and then we have to define the IP addresses also. So in the IP addresses, the CIDR blocks are allocated to the virtual networks, and that becomes a fixed IP address for that VNet. So what you can do is you can specify a range of IP addresses. Now, whenever we talk about a virtual network and the IP addresses, we primarily focus on the private IPs only. So this is the private IP that we are actually talking about. So I can reserve some IP address CIDR for our VNet, and that is the range of 40.0.0.0/16 I'm going to reserve. So now we'll create one subnet, and we'll name that subnet. So as we discussed, that subnets are the subcomponents of the VNet. So here you can see we have already created one subnet with the name public subnet. So likewise, we can add another subnet also, and let's name it to something like demo subnet. Right, and the subnet should have the IP address range, and that IP address range should be part of the VNet only. In V18, so same subnet address range you would be defining in the subnet as well. So that will be 40.0.1. or we can select 2.0/24. The rest of the things would be default. We are not attaching any route table as of now. So just click on OK, and here you can see that the subnet is created. Now once the subnet is created, now we are going to create a virtual machine inside that subnet, and for that we'll go to the search bar, and here we'll type virtual machines. Now we'll create a virtual machine in the same VNet, that is the test VNet, and inside the demo subnet, so that our virtual machine gets the private IP address from the subnet that has been created in the VNet itself. So what you need to do is you have to open up the virtual machines, click on add, and here you should add a new virtual machine. So you should select the name of the virtual machine and the network details, where we would be defining the VNet as well as the subnet where the virtual machine should be created. So in the subscription, we'll go with the free tier, and in the resource group, we'll go with the demo that has already been created. We'll put a virtual machine name, something like test VM, and the rest of the things will be default. So we'll quickly skip the disk check also. Now in the networking, we would be selecting the test VNet as our virtual network, and in the subnet we would be selecting the demo subnet. So that is the recently one added in the test VNet, and we want that our virtual machine should be part of that subnet only. Now obviously, since we are creating a virtual machine, so it should be part of, it should have the public IP also assigned, since from the public network we need to access those virtual machines. So we'll keep it enabled, right? And the next would be the default settings that we are going to proceed with. So let's review all the configurations and then create your virtual machine. So here you can see that our virtual machine has been created, validation has been passed, and it takes a couple of minutes to get that updated. So let's wait for a few more minutes so that our virtual machine is ready. And primarily what we want to look into is that our virtual machine is created in a correct VNet, and it gets the private IP address from the subnet that has been part of the VNet which has been defined in the creation of a virtual machine. So let's wait for a couple of more minutes and we'll look into the status of the VNet. Now you can see here our test virtual machine has been created. Now what we wanted to look into is that our virtual machine is created in a correct subnet or not, and that is something which we can validate by checking the private IP address. So it got the private IP from the range of the IP address that we have specified in the subnet. Now in order to access this particular virtual machine, you have to use the public IP, since we have to access it from the internet. So from the private IP, this virtual machine will not be accessible. So that's the reason that when we created a virtual machine, we allocated the public IP address also for this instance. So that is with respect to the virtual network and the demonstration on it, and how we can create a VNet and the subcomponents of the VNet, how they are associated or interlinked with each other, and that actually creates a kind of an isolated environment on the public cloud, which gives you the understanding that you can work into just like an on-prem environment.
Today we will discuss what should an individual learn in the year 2021. Let's wait for an ample amount of time so that few more people can tune in. By the time, please allow me to tell you that we have daily updates on multiple technologies. So if you are the tech geek in a continuous hunt for latest technological trends, then consider getting subscribed to our YouTube channel and hit the bell icon so that you can never miss an update from our end. So we have a few more people now. Hi everyone, welcome to Simplilearn. So without further ado, let's get started. Back in the 2000s, organizations were utterly dependent on purchased servers for their IT infrastructure. These servers not only came with limited functionality, but were also very expensive. The traditional way of storing and managing data was costly and complicated. It required a massive amount of hardware and complex software to run. All these issues were resolved using cloud computing. Rather than owning their computing infrastructures, organizations were able to scale up or scale down resources based on the requirement. Companies providing these computing services are called as cloud providers. According to C# Corner, the two popular cloud providers in the cloud market are Amazon AWS and Microsoft Azure. Now, let's take a step back and talk about a question. What should an individual learn in the year 2021? Amazon Web Services or Microsoft Azure? Though this question is tricky, we need to understand which cloud provider is the best option to choose. Now, let's take a brief look at both of these cloud providers. Amazon Web Services is an evolving cloud computing platform that offers various services such as compute power, storage, database, content delivery, and other resources to help business scale and grow. AWS services are provided based on a subscription basis. Similarly, Microsoft Azure provides a set of cloud services to design, create, and monitor applications on a network. Talking about the general features, Amazon Web Services was established in the year 2006. Today, it holds a market share of 31.7%, whereas Microsoft Azure was started in the year 2010 and now has a market share up to 16.8%. Amazon AWS is the world's most broadly adopted cloud platform. It offers up to 165 services globally. These services are used by millions of companies like Spotify, Netflix, Facebook, BBC, etc. Talking about Netflix, the company moved its IT operations to AWS in the year 2009. AWS was able to solve the company's scalability and data management issues. Azure offers several services in various categories, including artificial intelligence, analytics, containers, IoT, and many more. These services are used by many famous companies like Accenture, LinkedIn, Stack, eBay, and Samsung. Accenture chose Microsoft Azure to boost productivity and provide better security to its employees. The AWS pricing model is based on an hourly basis. With AWS, every individual pays only for the services that are required for his work. Every person only pays for the services he consumes. Azure pricing is charged on a per minute basis. The payment system is very simple and doesn't involve any long-term contracts. Microsoft Azure is free of upfront costs and cancellation fees, and only users pay for the resources they consume. With Azure and Amazon AWS, there are no additional costs or termination fees. Moving on to the next factor, let's talk about availability zones. Availability zones are isolated data centers with independent power and networking. These zones protect applications and files from data center failures. In total, AWS has nearly 77 availability zones within 24 geographic regions around the world. The company plans to establish 9 more AWS availability zones and 3 more AWS regions in Indonesia, Japan, and Spain. On the other hand, Microsoft Azure has many isolated availability zones. These zones are located within an Azure region, and they provide fast network connectivity. Azure has 44 availability zones around the world. The company is planning to launch 12 more zones. Now, after discussing the availability zones, let's talk about the services. The services that I am going to compare here come under the following domains: compute, storage, database, security, and finally networking. AWS and Azure provide a wide variety of services with low migration costs so that every individual can shift his or her current traditional infrastructure to cloud platform very easily. AWS EC2 is a suitable example of compute services. EC2 is a web service that aims to make life easier for developers by providing secure and resizable compute capacity in the cloud. It can be integrated to several other services like S3, IAM, CloudFormation, etc. Azure has a small service called Azure Virtual Machine Image. It helps the developers to develop and design identical virtual machines in the matter of minutes. Azure virtual machines are becoming more popular among IT infrastructures. These machines let an individual create and use virtual machines in the cloud as IaaS or infrastructure as a service. Virtual machines can be created using Azure Portal, Azure PowerShell, and ARM templates, Azure CLI or Client Software Development Kits. Next comes Amazon S3. It is the best example for storage service. Simple Storage Service is an object storage service designed to store and recover any information from anywhere via the internet. Amazon S3 facilitates storage through a web service interface. The service provides 99.9% durability and 99.9% availability of objects. It has the capacity of storing computer files up to 5 terabytes in size. On the other hand, Azure provides a similar service called Blob Storage Service. This service provides a large amount of storage and is highly scalable. It stores an object in the tiers depending on how often the data is being accessed. Blob storage supports widely used frameworks like Java, .NET, Python, and Node.js. It is the only cloud storage service in Microsoft Azure that offers a premium SSD-based object storage tier for low latency networks. AWS provides a secure cloud platform where every individual can manage and deploy their applications. Compared to the on-premises environment, AWS security offers a high level of data protection at a lower cost. For security purposes, IAM is a suitable service. AWS Identity and Access Management is a cloud service that controls and manages AWS resources securely. It has no upfront cost, also gives a facility to create and maintain services within a specific set of users on your AWS resources. In Microsoft Azure, Azure Active Directory, or in short also called as Azure AD, is a web service which provides MFA, multi-factor authentication features to users in order to protect their data from cyber attacks. Next is Amazon RDS. It is a web service designed to simplify the setup, operation, and scaling of a relational database. It is simple to set up, use, and scale when required by users. It provides inexpensive and resizable capacity and automates several tasks such as hardware provisioning, database setup, patching, and backups. On the other side, the Azure SQL database automatically updates and backups data in order to focus on the development of applications. Not just that, it also manages database services and responds to client requirements. Client requirements such as scalability of a service, data backup, and high availability of database. Similarly, these cloud providers have plenty of services that help users build and deploy their applications effectively. Moving on to the next topic, let us focus on integrating AWS and Azure with open source tools. Now, we will explain how to build a pipeline using Jenkins along with one of the services of Amazon Web Services, that is the EC2. In this integration process, we have a sample Python application called as a Docker file. This Docker file will consist of a Python-based image. The Docker file builds a pipeline in order to create a Docker image upon pushing the code to the repository. Later, the new image is used to start a new AWS service on an ECS cluster. Now, let's have a look at how the integration of open source tools happen in Azure. In your Azure Cloud application, DevOps tools like Docker, Maven, and Jenkins can be integrated. In case you want to integrate the Jenkins pipeline, go to Project and create a subscription, followed by Jenkins. You can specify the required filters based on your requirement. Then choose your endpoint for Azure DevOps to communicate with Jenkins. So that was all about Amazon AWS and Microsoft Azure. Both AWS and Azure are honored to be on top of all other cloud providers. Both provide all necessary features like scalability, high availability, and security. But the moment I hear about choosing the best one, I have to say that all that depends upon the individual business needs. Both cloud providers are the certified ones that hold immense value in the current cloud service market.
Hey guys, I'm Rahul and I'll be representing Amazon Web Services.
I'm Chinmayi and I'll be representing Microsoft Azure.
And I'm Shruti and I'll be representing Google Cloud Platform. So welcome to this video on AWS versus Azure versus GCP.
Talking about market share, Amazon Web Services leads with around 32% of the worldwide public cloud share.
Azure owns up to 16% of the worldwide market share.
And GCP owns around 9% of the world's market share.
Let's talk about each of these service providers in detail. AWS provides services that enable users to create and deploy applications over the cloud. These services are accessible via the internet. AWS, being the oldest of the lot, was launched in the year 2006.
Azure, launched in 2010, is a computing platform that offers a wide range of services to build, manage, and deploy applications on the network using tools and frameworks.
Launched in the year 2008, GCP offers application development and integration services for its end users. In addition to cloud management, it also offers services for big data, machine learning, and IoT.
Now let's talk about availability zones. These are isolated locations within data center regions from which public cloud services originate and operate. Talking about AWS, they have 69 availability zones within 22 geographical regions. This includes regions in the United States, South America, Europe, and Asia Pacific. They are also predicted to have 12 more additions in the future.
Azure, available in 140 countries, has over 54 regions worldwide grouped into 6 geographies. These geographical locations have more than 100 data centers.
GCP is available in 200 plus countries across the world. As of today, GCP is present in 61 zones and 20 regions, with Osaka and Zurich being the newly added regions.
Now let's talk about pricing. These services follow the pay-as-you-go approach. You pay only for the individual services you need for as long as you use them without requiring long-term contracts or complex licensing. Now on screen, you can see the pricing for each of these cloud service providers with respect to various instances like general purpose, compute optimized, memory optimized, and GPU. Now let's talk about the compute services offered. First off, we have virtual servers. For AWS, we have EC2. It is a web service which eliminates the need to invest in hardware so that you can develop and deploy applications in a faster manner. It provides virtual machines in which you can run your applications.
Azure's virtual machines is one of the several types of computing resources that Azure offers. Azure gives the user the flexibility to deploy and manage a virtual environment inside a virtual network.
GCP's VM service enables users to build, deploy, and manage virtual machines to run workloads on the cloud.
Now let's talk about the pricing of each of these services. AWS EC2 is free to try. It is packaged as part of AWS's free tier that lasts for 12 months and provides 750 hours per month of both Linux and Windows virtual machines.
Azure Virtual Machine Service is a part of the free tier that offers this service for about 750 hours per month for a year. The user gets access to Windows and Linux virtual machines.
GCP's VM service is a part of a free tier that includes micro-instance per month for up to 12 months.
Now let's talk about Platform as a Service or PaaS services. For AWS, Elastic Beanstalk is an easy-to-use service for deploying and scaling web applications and services developed with Java, .NET, Node.js, Python, and much more. It is used for maintaining capacity, provisioning, load balancing, auto-scaling, and application health monitoring.
The PaaS backbone utilizes virtualization techniques where the virtual machine is independent of the actual hardware that hosts it. Hence, the user can write application code without worrying about the underlying hardware.
Google App Engine is a cloud computing platform as a service which is used by developers for hosting and building apps in Google data centers. The App Engine requires the apps to be written in Java or Python and store data in Google Bigtable and use the Google query language for this.
Next, let's talk about virtual private server services. AWS provides Lightsail. It provides everything you need to build an application or a website along with the cost-effective monthly plan and minimum number of configurations.
In simple words, VM image is a more comprehensive image for Microsoft Azure virtual machines. It helps the user create many identical virtual machines in a matter of minutes.
Unfortunately, GCP does not offer any similar service.
Next up, we have serverless computing services. AWS has Lambda. It is a serverless compute service that lets you run your code without facilitating and managing servers. You only pay for the compute time you use. It is used to execute backend code and scales automatically when required.
Azure Functions is a serverless compute service that lets you run event-triggered code without having to explicitly provision or manage infrastructure. This allows the users to build applications using serverless simple functions with the programming language of their choice.
GCP Cloud Functions make it easy for developers to run and scale code in the cloud and build event-driven serverless applications. It is highly available and fault-tolerant.
Now let's talk about storage services offered by each of these service providers. First off, we have object storage. AWS provides S3. It is an object storage that provides industry standard scalability, data availability, and performance. It is extremely durable and can be used for storing as well as recovering information or data from anywhere over the internet.
Blob storage is an Azure feature that lets developers store unstructured data in Microsoft's cloud platform. Along with storage, it also offers scalability. It stores the data in the form of tiers depending on how often data is being accessed.
Google Cloud Storage is an online storage web service for storing and accessing data on Google Cloud Platform infrastructure. Unlike the Google Drive, Google Cloud Storage is more suitable for enterprises. It also stores objects that are organized into buckets.
Amazon provides EBS or Elastic Block Store. It provides high-performance block storage and is used along with EC2 instances for workloads that are transaction or throughput intensive.
Azure Managed Disk is a virtual hard disk. You can think of it like a physical disk in an on-premises server but virtualized. These managed disks allow the users to create up to 10,000 VM disks in a single subscription.
Persistent storage is a data storage device that retains data after power to the device is shut off. Google Persistent Disk is durable and high-performance block storage for GCP. Persistent Disk provides storage which can be attached to instances running in either Google Compute Engine or Kubernetes Engine.
Next up, we have disaster recovery services. AWS provides a cloud-based recovery service that ensures that your IT infrastructure and data are recovered while minimizing the amount of downtime that could be experienced.
Site recovery helps ensure business continuity by keeping business apps and workloads running during outages. It allows recovery by orchestrating and automating the replication process of Azure virtual machines between regions.
Unfortunately, GCP has no disaster recovery service.
Next, let's talk about database services. First off, for AWS, we have RDS or Relational Database Service. It is a web service that's cost-effective and automates administration tasks. Basically, it simplifies the setup, operation, and scaling of a relational database.
Microsoft Azure SQL Database is a software as a service platform that includes built-in intelligence that learns app patterns and adapts to maximize performance, reliability, and data protection. It also eases the migration of SQL Server databases without changing the user's applications.
Cloud SQL is a fully managed database service which is easy to set up, maintain, and administer relational PostgreSQL, MySQL, and SQL Server databases in the cloud. Hosted on GCP, Cloud SQL provides a database infrastructure for applications running anywhere.
Next, we have NoSQL database services. AWS provides DynamoDB, which is a managed, durable database that provides security, backup and restore, and in-memory caching for applications. It is well known for its low latency and scalable performance.
Azure Cosmos DB is Microsoft's globally distributed multi-model database service. It natively supports NoSQL created for low latency and scalable applications.
GCP Cloud Data Store is a NoSQL database service offered by Google on the GCP. It handles replication and scales automatically to your application's load. With Cloud Data Store's interface, data can easily be accessed by any deployment target.
Now let's talk about the key cloud tools for each of these service providers. For AWS, in networking and content delivery, we have AWS Route 53 and AWS CloudFront. For management, we have AWS CloudWatch and AWS CloudFormation. For development, we have AWS CodeStart and AWS CodeBuild. For security, we have IAM and Key Management Service.
For Microsoft Azure, networking and content delivery, we have Content Delivery Network and ExpressRoute. For management tools, we have Azure Advisor and Network Watcher. For development tools, for management, we have Azure Advisor and Network Watcher. For development, we have Visual Studio IDE and Azure Blob Studio. For security, we have Azure Security Center and Azure Active Directory.
For GCP, we have the following tools. For networking and content delivery, we have Cloud CDN and Cloud DNS. For management, we have Stack Driver and GCP Monitoring. For development, we have Cloud Build and Cloud SDK. And finally, for security, we have Google Cloud IAM and Google and Cloud Security Scanner.
Now let's talk about the companies using these cloud providers. For AWS, we have Netflix, Unilever, Kellogg's, NASA, Nokia, and Adobe.
Pixar, Samsung, eBay, Fujitsu, EMC, and BMW, among others, use Microsoft Azure.
So as seen on your screens, the companies that use GCP are Spotify, HSBC, Snapchat, Twitter, PayPal, and 20th Century Fox.
Let's talk about the advantages of each of these services. Amazon provides enterprise-friendly services. You can leverage Amazon's 15 years of experience delivering large-scale global infrastructure, and it still continues to hone and innovate its infrastructure management skills and capabilities. Secondly, it provides instant access to resources. AWS is designed to allow application providers, ISVs, and vendors to quickly and securely host your applications, whether an existing application or a new SaaS-based application. speed and agility. AWS provides you access to its services within minutes. All you need to select is what you require and you can proceed. You can access each of these applications anytime you need them. And finally, it's secure and reliable. Amazon enables you to innovate and scale your application in a secure environment. It secures and hardens your infrastructure. More importantly, it provides security at a cheaper cost than on-premise environments.
Now talking about some of the advantages of Azure. Microsoft Azure offers better development operations. It also provides strong security profile. Azure has a strong focus on security, following the standard security model of detect, assess, diagnose, stabilize, and close. Azure also provides a cost-effective solution. The cloud environment allows businesses to launch both customer applications and internal apps in the cloud, which saves on IT infrastructure costs. Hence, it's OpEx friendly.
Let's now look at the advantages of GCP. Google bills in minute-level increments, so you only pay for the compute time you use. They also provide discounted prices for long-running workloads. For example, you use the VM for a month and get a discount. GCP also provides live migration of virtual machines. Live migration is the process of moving a running VM from one physical server to another without disrupting its availability to the users. This is a very important differentiator for Google Cloud compared to other cloud providers. GCP provides automatic scalability. This allows a site's container scale to as many CPUs as needed. Google Cloud Storage is designed for 99.9% durability. It creates server backup and stores them in a user-configured location.
Let's talk about the disadvantages of each of these services. For AWS, there's a limitation of the EC2 service. AWS provides limitations on resources that vary from region to region. There may be a limit to the number of instances that can be created. However, you can request for these limits to be increased. Secondly, they have a technical support fee. AWS charges you for immediate support, and you can opt for any of these packages. Developer, which costs $29 per month, Business, which costs more than $100, and Enterprise, that costs more than $15,000. It has certain network connectivity issues. It also has general issues when you move to the cloud, like downtime, limited control, backup protection, and so on. However, most of these are temporary issues and can be handled over time.
Talking about some of the disadvantages of Microsoft Azure. Codebase is different when working offline and it requires modification when working on the cloud. PaaS ecosystem is not as efficient as IaaS. Azure Management Console is frustrating to work with. It is slow to respond and update and requires far too many clicks to achieve simple tasks. Azure Backup is intended for backing up and restoring data located on your on-premises servers to the cloud. That's a great feature, but it's not really useful for doing bare metal restores of servers in a remote data center.
Let's now look into the disadvantages of GCP. So when it comes to cloud providers, the support fee is very minimal, but in the case of GCP, it is quite costly. It is around $150 per month for the most basic service. Similar to AWS S3, GCP has a complex pricing schema. Also, it is not very budget friendly when it comes to downloading data from Google Cloud Storage.
I would like to welcome you to this Azure interview preparation session. Knowing Azure is one thing, having worked on Azure is another thing, and being able to answer interview questions in Azure is a totally different thing. Although one helps the other, it's still different skills. And our aim through this video is to prepare you with common product and scenario-based interview questions. So why wait? Let's get started. A common cloud interview question is, what's the difference between SaaS, PaaS, and IaaS? We all know that a software as a service is thin client model of software provisioning, where client in this case usually is simply a web browser providing the point of access to softwares running on the servers. Now, SaaS is the most familiar form of cloud service for customers. SaaS moves the task of managing software and its deployment to third-party services, meaning the vendor actually gets to manage all that. So SaaS is software as a service involving applications being consumed and used by organizations. So it's generally using an application, and usually organizations pay for their use of this particular application. Now, some examples of SaaS would include Office 365. Salesforce is another very good example of SaaS, and a lot of Google apps and storage solutions like Box and Dropbox are a very good example of software as a service. Talking about platform as a service, or PaaS, it actually functions at the lower level than SaaS. Now, typically it provides a platform on which software can be developed and deployed. Now here we develop the software, we deploy the software. Now PaaS actually provides an abstract of much of the work dealing with servers and giving client an environment in which the operating system and the server software and the hardwares and the network are managed and taken care. In other words, with a platform as a service, all the things that I've mentioned, like the servers, the server software, the hardware, everything is managed by the provider, and we can focus on business side of the scalability, and we can focus on application development of our product or the service. So in short, platform as a service is a service that enables developers to build and work with applications without even having to worry about the infrastructure or management of the underlying hosting environments. And some examples of PaaS in Azure is SQL and Azure Storage. Talking about infrastructure as a service, IaaS, now this is moving down the stack even further. Now we get to the fundamental building block of the cloud service, which is infrastructure as a service, IaaS. Now IaaS is fully of highly automated scalable computer resources. IaaS is full of storage. IaaS is full of the network capability. That's what IaaS is. Now IaaS clients have direct access to the servers and storage, just as they would to do traditional servers. But in this case, it's going to be in the cloud. In this case, it's going to be more scalable. So IaaS is very similar to what you would do in your on-premises physical data center. But when we talk about IaaS, we get to do everything, but it's stored in the cloud. So if we need to build a definition around IaaS or infrastructure as a service provides users with components. It provides components. It does not give us a built environment. It simply provides a component such as operating system, networking capabilities, and a lot more. Now this is a paid for based on the usage and can be used to host applications. In other words, this is pay as you go type. The more you use, the more you pay. The less you use, the less you pay. And some of the examples of IaaS in Azure is virtual machine. That's a great example for IaaS, and VNets for networking. That's another good example for IaaS in Azure. Another common question in Azure Interview is, what are the instant types offered by Azure? The main intention of this question is, how well have you understood the different offerings in Azure, and how well are you trained to pick the right offering for the right service? Now one size does not fit all, and there are a lot of services in Azure that under the carpet it does the same thing, but depending on how different your requirement is, we'll have to pick the appropriate service. So this question, what are the different instant types offered by Azure, it's to test how well have you used the product and services available in Azure, and how well have you applied them for the given requirement. You shouldn't be provisioning more, you shouldn't be provisioning less at the same time. So it's kind of matching the right service to the right requirement. So what are the instant types offered by Azure? As you see in the list, we have general purpose, compute optimized, memory optimized, storage optimized, GPU virtual machines, and high performance compute virtual machines. Now answering just the names won't be enough in an interview. You'll have to go further and explain why and in what scenario you would use general purpose, and what are the use cases, what type of servers is a good fit for a general purpose, and what type is a good fit for compute optimized, so on and so forth. And that's exactly what we're going to do now. So the general purpose VMs, they provide a balanced CPU to memory ratio, and it's very good for testing, very good for a development environment, very good for small and medium databases, and also for low to medium traffic web servers. And some of the use cases are, like we said, test servers, low traffic web servers, small to medium databases, some enterprise grade applications. It's also good for relational database. It's also good for servers used for in-memory caching. It's also good for some small analytic database, very good for microservices. And if you're trying to build a proof of concept for an idea that
you just have or just parked, this is another good server for doing proof of concepts, because you're not going to send actual traffic to it. I just want to show that your idea works. So general purpose server is a very good use case for those scenarios. And the largest instance size we can get in general purpose is standard D64 V3. Which comes with 256 gigabit of memory and 1600 gigabit of SSD temporary storage. On the other hand, compute optimized VMs have a high CPU to memory ratio and are very good for medium traffic web servers, very good for batch processing servers, very good for application servers. Now, because it's compute optimized and compute means CPU, it's an excellent choice for workloads that demand faster CPU but does not need as much memory or temporary storage virtual CPU. Some of the workloads that run very well on compute optimized are analytic workloads, gaming servers require more CPU, they run really well. Batch processing are some of the applications that can be placed in compute optimized, and by doing that we get the actual benefit of the compute optimized instance. And the largest instance size or the largest instance size type is standard F72's V2, and here we get 144 gigabit of memory and 576 gigabit of SSD temporary storage in compute optimized VMs. In the same lines, memory optimized VM, they offer high memory to CPU ratio and that are great for databases. Databases require more memory, so it's a great fit for a database, and it's a great fit for medium to large scale caches, applications that require in-memory analytics. So this memory optimized, memory is more, so it's very good for in-memory analytics applications. And the largest instance size we get here is standard M128M, and look at the gigabit of memory. It's 3892 gigabit of memory, and look at the temporary storage. It's 1400 gigabit of temporary storage. On the same lines, storage optimized. Now I guess I don't have to explain to you what storage optimized is used for. You might have easily guessed looking at the flow. Yes, storage optimized VM offer high disk throughput and IO and are very ideal for big data, SQL, NoSQL databases, data warehousing servers, large transactional databases, and a lot more. And some of the examples of the applications that can be launched on storage optimized are Cassandra, MongoDB, Cloudera, Redis. These are some familiar applications that can get benefited when we run them on storage optimized. And one difference between storage optimized and the other servers are they are generally optimized to use the local disk on the node attached directly to the VM rather than using an durable disk, which is actually a remote disk space. Now what does this allow? This allows for greater input outputs per second or throughput for the workload. So that's what we get. A greater throughput, a greater input outputs per second is what we get when we use storage optimized. And the largest instance size available in storage optimized is standard L32S, and the memory is 256 gigabit, and look at the temporary storage. It's 5630 gigabit of temporary storage. GPU type VMs, easy to guess. GPU optimized VMs are specialized virtual machines available with multiple GPUs attached to them. Now these sizes are designed for, or these VMs are designed for compute intensive, graphic intensive visualization workloads that require a lot of graphical processing unit attached to it. So in short, these are virtual machines that specialize in heavy graphic rendering and video editing. It also helps with model training and interferencing with standard ND24RS, which has 448 gigabit of memory and 2948 gigabit of temporary storage. And the last but not the least, but the best, is high performance compute or Azure H series virtual machines. Now they are the latest in high performance computing VMs and are aimed to handle workloads like batch processing, analytic, molecular modeling, and fluid dynamics. A lot of complicated applications in this VM.
and this is the fastest and powerful CPU virtual machine with optional high throughput interfaces. And the largest instance size that's available is a standard L32S, which comes with 224 gigabit of memory and 2000 gigabit of SSD temporary storage. And a third common question is, what are the deployment environments offered by Azure? There are two main deployment environments. One is the staging environment and the other one is the production environment. Now in staging environment, let's talk about staging first. So when you're deploying a web app or web app on Linux, you can deploy them to a separate slot instead of the default production slot when running them in standard premium or isolated app service plan tiers. Now the deployment slots are actually live app with their own host name, and at a later point the staging environment can be swapped with the production environment. So why do we need an staging environment? What are the benefit of it? So the benefit of deploying our application to a non-production or staging environment, it provides a platform to validate changes to our application before it can be made live in the production environment. And in the staging environment, the app can be identified using the Azure's global unique identifier, also called as the GUID URL. And it's very similar to the production URL, except that it has a custom name in front of it that identifies it as the staging environment. And for production environment, this is the live production environment that's serving customers' requests, that's serving the customer content. Now it can be slightly different from the staging environment in a way that the URL that's used to identify the production environment, that's more of an DNS friendly name, like the name of the actual service.cloudapp.net. That way it differs. In case of staging environment, you have a custom name right before it, so the custom name and then the cloudapp.net, but in this case you get the direct service name as the name of the URL. So this is live production environment which receives and handles and serves customer traffic. Another commonly asked question in Azure is what are the advantages of scaling in Azure? The actual thought behind the question is to see how much have you understood scaling, how much have you seen and how much have you applied the scaling effect in the production environment and have received benefits in return. So let's talk about it. Advantages of scaling in Azure. Some of the advantages are we get the maximum application performance. Now auto scaling is a built-in feature for the cloud services, be it AWS, Azure, Google, and a couple of other cloud service providers. It's a built-in feature for a cloud service. A cloud service should be auto scalable, and that includes mobile services, virtual machines, and when we run our applications on mobile services or virtual machines, the website actually gets the best performance during the change in the demand. Again, different applications might require different performance needs. For example, for some apps the performance is measured based on memory, and another good example is the fluctuating demand. For example, you could have a web app that handles millions of requests during the day and literally nothing at the night. And auto scaling this environment, any of these environment will automatically scale or fatten your environment so to receive all the incoming traffic, and during lean period it actually gets slimmer and slimmer so to help you with the cost. So it actually maximizes the performance. That's what auto scaling does. And like we said, auto scaling scales up and scales down based on demand. It not only scales up but also scales down so to help you with the cost. And if you know the particular pattern in which the application is going to receive traffic, then we can very well go ahead and schedule scaling to our application or schedule scaling that infrastructure based on time. If we already know that Monday to Friday, that's the traffic that I would get, and it's a constant one. It's not a public facing, but it's an internal application. So I know all the 500 users or the 1,000 or the 5,000 users who will be using it. So at any given point, it's just 5,000 users. It's not going to go beyond that. And during Saturday and Sunday, literally nobody's going to be in office. So no load at all. So in that case, I pretty much know how the pattern is going to be. I can go for scheduled scaling if I know the pattern. And auto scaling, like I said, not only helps with keeping the application highly available, it also helps with the cost effectiveness of our infrastructure. So anytime there's a VM or a group of VMs running on less CPU, auto scaling is going to actually get the environment slimmer and slimmer, so we're not unnecessarily running any resources and paying for it. If you're being interviewed for the infra side in Azure, this is another common question that gets asked. How are Windows Active Directory and Azure Active Directory different? Let's talk about the Windows Active Directory first. The non-cloud Windows Active Directory the service was released along with Windows 2000 Server Edition, and this Active Directory is essentially a database that helps organizations to organize the users, organize the computers, and a lot more. It provides authentication and authorization to the applications. Not only to the applications but also to file servers, to printers, and a lot of other on-premises resources. That's what the basic non-cloud Active Directory does. On the other hand, the Azure Active Directory is not designed to manage web-based services. The Azure Active Directory, on the other hand, was designed to support web-based services that use REST API interfaces for Office 365, Salesforce.com, etc. Unlike the plain Active Directory, this uses a completely different protocol. So protocol wise it's different, and the services that it supports is quite different. Now besides that, it also has a couple of other differences as well, and let's look at them. So the actual Active Directory, or the Windows Actual Directory, is a directory service that facilitates working with interconnected, complex, and different network resources in a very unified manner. On the other hand, Azure Active Directory is Microsoft's multi-tenant, cloud-based directory and identity management service. And the Windows Active Directory has 5 layers to store data, to store user details, and to issue the management certifications. On the other hand, Azure Active Directory integrates or compresses the 5 layers into just 2 layers. Here, Windows Active Directory works with on-premises servers like applications, file servers, and printers, etc. On the other hand, Azure Active Directory, it works on web-based services that use RESTful interfaces. If you're being hired for the development environment or for the cloud DevOps support environment, or even for the production support environment, you might find yourself being asked this question: what are the types of queues offered by Azure? Now Azure supports 2 types of queue mechanisms, the storage queue and the service bus queue. Let's talk about storage queue first. Now the storage queue, which are part of Azure storage infrastructure, it provides a simple REST-based interface, simple REST-based get, put, and peek interface. It provides reliable, persistent messaging within and between the services. It follows the pub-sub model, or a pub-sub messaging infrastructure, and it's best suited for users that need to store more than 80 GB of messages in the queue. It can provide logs for all the transactions executed against the user's queue. So that's what we get with storage queue. And on the other hand, service bus queue, the service bus queues are built on top of broader messaging infrastructure, and they are designed to integrate applications and applications component that can span multiple communication protocols. So that way it differs. So this is good for applications and components that may span multiple communication protocols and even totally different network environments. So in short, these service buses, or the service bus queues in Azure, are part of Azure's messaging infrastructure, and they integrate applications or application components that can actually span multiple different protocols and multiple different network environments. It also provides an first in first out style for delivery, and the user's queue size has to remain under 80 GB. Another familiar question is, what are the advantages of Azure Resource Manager? Now, the Resource Manager helps us to manage the usage of the application resources. This question is actually to test how well have you tested, how well have you used Resource Manager and have gotten the benefit of it. This question actually tests how easy it has become after the introduction of Resource Manager compared to when doing deployments or when provisioning resources without the Resource Manager. So let's get into the answers for the question. What are the advantages of Azure Resource Manager? In short, Resource Manager is called ARM. So the ARM helps deploy, manage and monitor all the resources for an application, a solution or a group. So all the interconnected application, all the interconnected services can be monitored as group using Resource Manager. And users can be granted to access to resources that they require within a Resource Manager. So in an account, I can have like 10 different resources created by a Resource Manager or a resource group created by Resource Managers, and I can allow, deny connection to those services or only to those services based on whether the user should be accessing one and not accessing the other. So that way it becomes easy to give access to a group of application. It helps in getting billing details for the group of resources. Now, which group is using more, which group is using less, and which group has contributed more to this month's bill, stuff like that. So those details can be obtained using Azure Resource Manager. And provisioning resources is made much easier with the help of this Resource Manager. Another question is how has integrating hybrid cloud been useful for Azure? Well, with the use of hybrid cloud, we get the best of both the worlds. So what's hybrid cloud? It's nothing but combining the public cloud and the private cloud and allowing data and applications to be shared between them. So whenever the compute or the processing demand fluctuates, hybrid cloud computing gives businesses the ability to seamlessly scale their on-premises infrastructure in the public cloud and handle any kind of overflow in the requirement or overflow in handling the application. So it really helps. It boosts the productivity of our on-premises application. So with the hybrid cloud, we get a greater efficiency with combination of Azure services, DevOps processes and tools for the application running in on-premises. And by having a hybrid cloud environment, users can take advantage of a constantly updated Azure service and other AWS marketplace applications for their on-premises environment. And the other benefit is with hybrid cloud environment, we can simply deploy applications regardless of its locations. In case of on-premises, we'll have to worry about the location, but when we expand our on-premises environment in the cloud, and we can pick any of the locations and simply deploy it in them. And this enables the applications to be created at a greater speed. What's federating in Azure SQL? Now this question is very specific about SQL. How can we scale the SQL database? Now this is a very good question or a valid question or an important question in the interview, because many customers or companies have not been able to meet the user demand because they could not scale out the databases. The theory of scaling out or adding servers to accommodate the increased workloads and traffic is not hard to understand, but the implications can be very complicated. The implications can be very expensive. We're well aware of scaling the web servers, that's very common, but how do we scale the database? So Microsoft provides the tools and technologies so we can scale out the database in the cloud, and that's what is called SQL or federation in Azure SQL. So the way we scale out the SQL database is by sharding the database. So sharding actually enables users to take advantages of the resources in the cloud. Not only that, it allows users to have their own database or a shared database amongst each other. Because we're creating a highly available database, because we're having shards in a database, it actually reduces the possibility of a single point of failure for our database. And more importantly, because we're sharding, because we're using federation in Azure SQL, it provides a cost-effective scaling of our databases by using cloud resources or by using billing only for the cloud resources that we have used. So no pre-provisioning, no over-provisioning. It provisions the right amount and we pay the right amount. Let's talk about this one. What are the different types of storage offered by Azure? Now, the different types of storage offered by Azure are, as you already know, and as you can see, they are Azure blob storages, table storages, file storage, and queue storage. So let's expand one after the other. Now, blob storage are nothing but a massive scalable object storage, and that's very good for storing text and binary data. And Azure Blob Storage is Microsoft's object storage solution for the cloud. Now, blob storage is optimized for storing massive amount of unstructured data that can be in form of text or in form of binary data. So in short, blob storage enables users to store unstructured data, and those data can be in the format of pictures, music, video files, and a lot more. And it stores them along with their metadata. And another advantage or another feature benefit that we get from blob storage is when an object is changed, it is verified to ensure it is of the latest version, number one. And number two, it provides maximum flexibility to optimize the user's storage needs. And this unstructured data is available to customers through an URL or an REST-based object storage. So they are the benefits that come along with the blob storage. Table storage, on the other hand, is a NoSQL store for schemaless storage of secured data. Now, this Azure Table Storage is a service that stores structured NoSQL data in the cloud. And because this table is schemaless, it's very easy to save your data. It's very easy to adapt your data as the need for your application grows. And this table storage is very fast and cost effective for many type of applications. So some of the type of data that we can store is table storage is good for flexible databases like user data for web applications, address book storage, device information storage, and if you want to store metadata, this is a very good use case to store them in Azure Table Storage. Azure Files is another storage. Here it's a managed file share for cloud or on-premises deployment. So file storage provides file sharing capabilities accessible by the server messaging block protocol, and this can be accessed from the cloud and this can be accessed from on-premises as well. Here in file storage, the data is protected by SMB 3.0 and HTTPS protocols. And the more important thing is Azure takes care of managing hardware and the operating system deployments for Azure file storage. So this additional file storage can be used when we want to burst the storage capacity in on-premises. So on-premises, the primary, and cloud is the secondary or the extended on-premises storage. So it actually improves the on-premises performance and capabilities for our on-premises data center. And then we have queues, Azure Queues. It's a messaging store for reliable messaging between the application components. So we spoke a little about this in the previous question. So the Azure Queue Storage is a service for storing a large amount of messages that can be accessed from anywhere in the world via HTTP or HTTPS protocol. In here, a single message can be up to 64 kilobits in size, and in a queue we can have millions of messages, and the limit can actually go up if we have not reached the limit of the storage account. So it's millions and millions of requests that can be stored in the storage queue or the queue storage. So the queue storage, in short, provides message queuing for large workloads, and it enables users to build flexible applications and separate the functions one from another, so one failing doesn't affect the other application which is running healthy. And this queue storage, it ensures the application is scalable and less prone to individual component failures because they are decoupled, separate now. It also helps in monitoring the queue, which ensures the customer's demands are met. So queue is a great place to monitor, or a great component to monitor, so we understand how much peak have we reached for a particular application, service, or a container. What is text analysis API in Azure Machine Learning? Now, text analysis is actually an cloud-based analytics API, and it provides an advanced natural language processing over the raw text. And it has got four main functions, like the sentiment analysis, and the key phrase analysis, language deduction, and a few other things. Now, what do you mean by sentiment analysis? Now, sentiment analysis is from the logs, from the comments, from the text comments that we receive, do an analysis and find out whether that's a positive or a negative statement. Now, if it is the API returns an sentiment score between 0 and 1, and 1 is positive and 0 is negative. And then in text analysis, we have a key phrase extraction, which is it will automatically extract the key phrase to quickly identify the main points in that key phrase. For example, if you're analyzing a text which says the food was delicious and there were wonderful stuff, then the API returns the main talking points of that phrase, like food is the main talking point, and wonderful stuffs, that was a main talking point. So that's another feature that this text analysis has. And then we have language deduction in text analysis, right? Irrespective of what you paste, it can try to gauge and try to align it to the 120 or up to 120 languages that it supports. So I can simply take text from the internet and I can paste it, and text analysis software is going to identify the language and then can run phrase and sentiment analysis on those texts. Right. So in short, text analysis is an API, a set of web services that can be used for text analysis. It can be used to analyze unstructured statement, sentiment analysis, key phrase extraction, and a lot more. And the results are generally between 0 and 1 being positive and 0 being the negative sentiment. There is no much training, or in other words, this is not as complicated as a couple of other text analysis softwares are available in the market. We can simply paste, we can simply upload the text, and we can call the service and it runs a sentiment analysis on it all by itself. Let's look at this question. What are the advantages of Azure Queue Storage? If you're going to work in a development environment, if you're going to work in an environment that embraces DevOps, this could be a question. What are the advantages of Azure Queue Storage? Now, Azure Queue Storage is built to flexibly operate the applications and separate the functions between the applications that run large workloads. So when we design applications for scale, these applications can be decoupled so that they can scale independently. A thing happening on an application is not dependent on another application, and anything happens to a section of the application will not affect the other application because they are now decoupled and connected through the queue storage. So the queue storage gives us asynchronous message queuing for communication between the applications, irrespective of whether they are running in the cloud or whether they are running in desktop or whether they are running on premises or on mobile devices. So in short, this queue storage enables message queuing for large workloads in a simple and cost-effective and a durable manner. Talking about the advantages is it provides rich client libraries for Java, Android, C++, PHP, Ruby, and a lot other services getting added during every new release from Azure. And the main advantage again is it enables users to build flexible apps and separate the functions for bigger or greater durability. Again, introduction of queues into our application, it ensures our users' applications are scalable and less prone to individual component failures, meaning one component failing is not going to take the whole application down. Right? If one component fails, it's just that component that fails. The rest are healthy and the rest are going to function. It also helps us to monitor the queues and ensure the servers aren't overwhelmed by sudden traffic bursts. So how much do I have in the queue kind of determines the traffic for my application. And if the queue is more, I can always go and auto scale my environment, and the queue is less, I can always go and shrink or make my environment thinner so it can save cost. And anytime there is more data in the queue, I can auto scale, monitor the metric and do auto scaling based on that metric. So the environment knows that there are more data coming in. I need to expand myself to handle that much amount of data. This is a very common question. What are the two kinds of Azure Web Service roles? Now, a service role is a set of managed and load balanced virtual machines that work to perform some task. and based on what it's going to run on top of it, is it going to run a web service or is it going to run a worker service, defines what kind of roles that gets attached or that goes on this virtual machines. So we have two types, web role and worker roles. The web role is a cloud service role that's configured to run web applications developed on programming languages, technologies, and majorly they support IIS, Internet Information Service, and they support ASP.NET, PHP, Windows Communication Foundation, and so on. So that's web roles. And these web roles, it automatically deploys and hosts application through the user's IIS, Internet Information Service. On the other hand, worker roles are roles that runs applications and service level tasks which generally do not require IIS. So IIS is actually the differentiating factor. So in worker roles, IIS is not installed by default. The worker roles are mainly used to perform supporting background process along with web roles and do tasks automatically compressing or uploading the images, running scripts, and or doing some changes in the database, getting new messages from the queue and processing, and a lot more. The work, the applications, or the work that does not require IIS. That's what this worker role does. Again, the main difference between the web role and the worker role is that the web role automatically deploys and hosts your application through IIS, whereas the worker role does not use IIS and runs our application as standalone. This is another classic question. What is Azure Service Fabric? So Azure Service Fabric is actually a distributed system platform that makes it easy to pack, deploy, and manage scalable and reliable microservices and containers. Now, Service Fabric also addresses some of the significant challenges in developing and managing cloud-native applications. And the problem that it addresses and fixes is, now developers and administrators can avoid complex infrastructure problems and focus on implementing mission-critical and demanding workloads that can be scaled and that can be managed through the console or from the single place. In short, Service Fabric provides a platform that makes the process of developing microservices and managing application lifecycle a lot easier. And the advantages of Service Fabric is that now we can produce application with faster time to market because all the worry about the infrastructure is taken away from us. We don't have to design an infrastructure. All that we need to worry about is simply the application and the application lifecycle. Again, the advantage is it supports Windows, it supports Linux. Not only that, it supports servers on premises and in the cloud. With Service Fabric, we can scale up our environment to even 1,000 machines in just a single command. Or if there is an immediate need for 1,000 machines, I can immediately scale them up to 1,000 machines. That's possible with Service Fabric. Now let's look at this question. You can expect this question if the customer is running hybrid environment, meaning having some of the applications in on-premises and running some of the applications from the cloud. And for some reason, when classifying the application that goes to the cloud and that stays on-premises, they have decided to keep the database in-house. So in that environment, a lot of customers do that. So in that environment, this is a classic and a scenario-based question. A client wants the front end of their application to be hosted on Azure in the cloud and wants the database to be hosted in on-premises for security reasons or to have full control on their databases. How do we go about suggesting a solution for this customer? The ideal solution in this scenario is to use the VNet-based point-to-site VPN solution. So all the front-end applications will be in the cloud and they'll be hosted in a VNet, and from the VNet they'll be connecting to the database through an point-to-site VPN. So the traffic and the writings and the reads are not coming through the internet but through a point-to-site VPN link that's connecting the Azure VNet and the on-premises environment. And this model or this approach or this solution is best suited for scenarios where there are only a limited number of resources that needs to be connected between on-premises and the cloud. This is a very common question. What's Azure Traffic Manager? Of course, we no more running applications on a single server. We no more running applications on or from a single environment. Right? The same application is being run from multiple environments within Azure, and it can be running from Azure and on-premise as well. So multiple environments between Azure and on-premises. And a lot of customers have such environment. And if you're facing an interview with such customer, this could be an ideal question. What is Azure Traffic Manager? Now, the Azure Traffic Manager is a DNS-based traffic load balancer that actually enables us to distribute traffic between services across Azure global regions. And by doing this, it provides a good availability and a good responsiveness to the application. And this traffic manager, it uses DNS to direct client requests to the most appropriate service endpoint based on the traffic routing logic and the health of the endpoints that it maintains. So in short, this traffic manager is a load balancer that enables users to provide high availability and responsiveness by distributing traffic in an optimal manner across the Azure when we run the same application in different regions. So some of the advantages or some of the use cases of using Azure Traffic Manager is it provides multiple automatic failover options. It also helps with reduced downtime. It also helps with the distribution of user traffic across multiple locations. So one location is not overloaded. And then it helps with users knowing from where our customers are getting connected from. That's another big use case with Azure Traffic Manager. Let's look at this question. Right, this is an ideal question. Now there are a group of servers connected together within an virtual network, and now we need to move them or create a separation between them. How do you go about achieving it? So the question goes like this. You need to isolate network traffic among VMs in a subnet, which is part of a virtual network with little downtime and impact on the users. So that's the given scenario. And the best way we can do it is create a new virtual network and move all the VMs in that subnet to the new virtual network. Now, this feature is not possible with a lot of other cloud service providers like AWS and a lot of other providers. Now, in those environments, we might need to shut down, we might need to stop the VM, create a new VM based on the image, and it's an hefty process. But here in Azure, I can simply move the VMs from one subnet to another virtual network without needing for any additional security like the network security group. I can simply isolate them if I need to by creating a simple new virtual network and moving the servers to the new virtual network. Look at this one. This is another common question. With respect to Azure, what is public, private, and hybrid cloud? So this is really to test how well have you understood the different cloud offerings in the market, public, private, and hybrid, or at least the three basic offerings in the market, public, private, and hybrid cloud. Now, the public cloud is the most common way of deploying cloud computing applications, and it has resources like servers, storage, and are owned and operated by third-party cloud service providers like Microsoft Azure. Microsoft Azure is a very good example of public cloud. So here, every component that the user is using is running only on Azure. That's public cloud. Right. Let me talk to you about some of the advantages of public cloud. Some of the advantages is low cost because there's no need to purchase hardware or software, and we pay only for the services that we use in public cloud. And there is literally no maintenance because the service provider maintains the environment for us. And with public cloud, we have nearly unlimited scalability, meaning we can get resources on demand and can meet our business requirements on demand. And the public clouds are very highly reliable because they have a vast network of servers and they ensure that our application does not fail. So there are some advantages of public cloud. Let's talk about private cloud. Now, private cloud consists of compute resources used extensively by one business or one organization. Now, this private cloud can be physically located at our organization's on-site data center, or it can be hosted by a third-party service provider. Whichever the case, the private cloud services and infrastructure are always maintained on a private network, and they're maintained on hardware and software that are dedicated solely for one organization or solely for your organization. So in short, private cloud in Azure is Azure services being run within an on-premises data center or on-premises data center used by the user to host systems or applications. And some of the advantages is it gives more security. Resources are not shared with others, so a higher level of control and security over our resource and application is possible. And then we have hybrid cloud. Now, hybrid cloud is the best of both worlds. So it combines the features of both public and private cloud. And some of the user components are being run on Azure and others within on-premises data center. So they kind of share the resources. In other words, they kind of share the application. Half of the application would be running in on-premises and half of them would be in the cloud, and they would be working in harmony to support the application and the business need. So that's hybrid cloud. This is another good example question that wants to test how well you pick services or how well have you understood Azure products and services and are picking the right service for the need. So the question would go like this: what kind of storage is best suited to handle unstructured data? There are a lot of storage options available, and the requirement here is what or which one would you choose for unstructured data? The answer for that question is blob storage, because blob storage is designed to support unstructured data. It works in this way. It places the data into different tiers based on how often they are accessed. Different tier means different performance. Different performance means different cost associated with it. So a lot of add-on advantages will we get when we use blob storage for unstructured data. In addition to it, any type of unstructured data can be stored in blob storage. This is not true with a couple of other storage options that we have in Azure. Only with blob storage we can store any type of unstructured data. And the data integrity is maintained every time an object is changed in the blob storage. And the best part is the blob storage helps increase applications performance and reduces the bandwidth consumption for that application. So they are the benefits that we get for blob storage, and blob storage are the ones that are well suited for unstructured data, and that's what your answer should be. It's really an 5-step process, and if we have done some basic labs with Azure, you can easily answer this question. So it's a 5-step process. First step is to log into the Azure. The second one is to create an resource or a resource manager. And within the resource manager, you would be selecting the resource. And then pick the operating system. Do you want Windows or Linux? And within Windows, what's the flavor you want? Or within Linux, what's the flavor you want? So decide on it. And then entering the relevant information like the name of the instance or the VM that we're going to launch, and the password, the URL that goes with it, and a couple of other relevant information that gets itself attached with the VM. And then select the size of the virtual machine. Different size, different types available for the kind of application and for the intensity of the application that will be running on top of it. So select the size of the virtual machine, review everything, whether they're good or not. If there are any changes required, go back and edit them, and then come back and launch, and your VM is there for you to start working within like 3 or 4 minutes, not even 5 minutes. Within 3 or 4 minutes, it gets ready and you can start working on it. So it's a quick and it's a 5-step process, and you should be able to answer it easily if you have done a few labs in Azure. Let's now look at some scenario-based question. You've been posed with a scenario. So we thought through it and we picked some common scenario-based questions that are being asked in an interview, and I thought we'll present it for you with the answers, with explanation, so you can get benefited through it. So let's look at this question. You're asked to make sure your virtual machines are able to communicate securely with each other to ensure security or to have good amount of security. What would you do? And the correct and the best answer for this would be using virtual network in Azure, which enables us to communicate with the internet securely, which enables us to communicate with the on-premises data center in a secure fashion. So the advantage of using virtual network is users can create their own private network, users can pick their own private IP ranges, users can create their own subnet, users can create their own routing between those two subnets. A lot more goes into that virtual network. So it's very customizable. And the users are provided with an isolated and highly secure environment for applications. It's completely isolated from other customers. It's completely isolated from other applications that are running in other virtual network that we own. So within our account, we can have multiple virtual networks, and one application running on a virtual machine is completely isolated from other applications running on other virtual machines. And of course, all traffic stays within the Azure network, Azure virtual machine, or within the Azure network, depending on how you set up the routing. If you have set up a routing to go or reach the internet, it's going to go, otherwise it's going to stay within Azure. If you have set up routing to reach on premises, then it's going to go and reach on premises, otherwise it's not going to go and reach on premises, it's going to stay within the Azure. And it also allows users to design their own network, like we already discussed, picking up IPs, picking routing, picking subnets, how many servers should be present in that particular subnet, or how many servers should that subnet accommodate, the size of the subnet, the IP ranges, the NATing, the masking of IPs, creating of VPN. All that's possible with the virtual network. So it really allows users to design their own network, and using virtual machine is how we secure applications in the cloud. Let's look at this other scenario. How do you ensure that every time a user logs in, they are not asked to re-enter the password as part of authentication? So you really don't want your users to re-enter the password every time they log in to a different application. Well, all the applications have their authentication mechanism in place. All of them wants to authenticate the user before they log in. Ensuring the user does not log in every time does not mean that wiping away all the authentication and authorization that's present in that application. You still need that in place, but how do you make the user hassle-free so they're not asked to re-enter the password or the same password again and again? Let's look at the options available. The first one is to enable Microsoft account authentication. Well, it's not going to fix, because with that the user will still need to re-enter the username and password. Deploy express route. It's not going to fix either, because express route is a network level service that connects on premises to the cloud. So that has got nothing to do with prompting or not prompting for password. And then we have set up VPN between on-premises data center and Azure, set up AD domain controller in VM, and implement integrated Windows authentication. Well, you can use the same username and password for on-premises and the cloud, but this setup, the VPN and the AD controller setup, it's not going to stop you asking for repeated passwords. So this is all about using the same password in on-premises and in the cloud, and this has got nothing to do with not prompting the user to re-enter the password. All right, so that's same password is different from not prompting the user to re-enter the password. They are two different scenarios, so that is also out of the equation. And the last one is configure AD sync to use single sign-on. That's the right one. So when we configure the AD to use single sign-on, then it's not going to ask for the username and password every time we access an application, because we have logged in, and that login is going to stay active for like 24 hours or so, depending on how you configure it. And within that time, you can access a lot of other applications, and it's not going to ask for the username and password, because you already have a single signed on and you have signed in using the right credentials. Let's look at this one. You need to ensure that virtual machines remain available while migrating to Azure. What would be the appropriate service to use? Right, let's look at the options. Traffic Manager. Traffic Manager is literally an DNS service. And then let's look at the other one, update domains. It again has to do with Traffic Manager, updating the URL. So the Traffic Manager gets updated and then starts sending requests to that particular URL. It's going to take some downtime, because when we update the URL, they will have to be populated to all different places, and it takes time. So within that time, any user trying to access, it's going to fail. And then we have Express Route and Cloud Services. Express Route could be in fact, it's the right answer, because Express Route, it's an extension of our on-premises and cloud environment. And in this question, it really comes out from a customer who's having an hybrid environment. So they have applications running in on-premises, they have applications running in the cloud, and they want to have a way to migrate applications from on-premises to the cloud. In other words, kind of do a cutover between on-premises and the cloud. And this express route is a service that connects between on-premises and the cloud. So when you do the cutover, the traffic is now sent to the cloud instead of being handled in on-premises. In fact, the services and the application is getting shut down in on-premises. So the request will come in the same pattern. Instead of they being handled in on-premises, they are now routed to the cloud using express route, and the API calls get addressed or the queries gets answered in the cloud through the express route service. Look at this question. You are an administrator for a website called WebGame, and you are required to validate and deploy changes made to your website by your development team with minimum downtime. So the real question is, how do you validate the deployment changes that's made by the development team? Let's look at the options. Create a new linked resource, create a staging environment for the site, enable remote debugging on the website, and then create a new website. Well, why would you want to create a new website? Just to validate the changes. And doing a remote debugging is not going to help, because debugging only captures logs of the changes happening. It does not do anything with validating the changes. Create a staging environment could be or is the right answer, because when we have staging environments, anything that we run on production can be run on staging environment, and any failures that would happen in production, if we simply run it in production, can be captured when we run the application in the staging environment. So that way, staging environment is a very helpful and useful service, and that way I can catch any errors. In other words, I can validate the changes that were done by my development team before I move it to production, and that reduces the downtime in the production environment. Look at this one last question that we have for you. It's our standard tier application is used across the world and uses Azure Website Standard Tier. It uses large amount of image files, so you can get it. This could be an e-commerce website which has a lot of pictures in it, and this is causing the application to load slow. How can we handle this situation? Let's look at the options given. Configure blob storage with custom domain. Well, this application has pictures, but only the pictures is not all that the application has. Alright, so configuring blob storage might not help. This could be an very interactive website, and that can't be run from blob storage. Let's look at the other options. Configure Azure website auto scaling to increase instances at high loads. Now, it's the picture that's causing issues for the website. It's not the CPU, or it's not the memory unavailable, memory not enough, that's causing the application to be slow. So we need to identify what's causing the application to be slow. So it's not the CPU, it's not the memory. So configure Azure for auto scaling is not going to help. And then what are the other options? Let's see. Configure Azure CDN to cache all responses from the application's web endpoint. A CDN could be the right answer, but look at that. It says CDN to cache all responses from the application's web endpoint. CDN is not designed for that. Though it can do it, that's not the best way to use CDN to capture all responses from the application's web endpoint. The proper design for CDN would be to cache the frequently used ones. In other words, cache the static content, which are photos, videos, logos, and pictures, and a lot more. Static content that never changes. Let's look at the last option. Configure Azure CDN to cache site images and content stored in Azure blob storage. Absolutely correct. So here we will have to redesign the application to store the pictures, high quality, lazy loading or slow loading pictures, because of the high quality and the bigger size. So store them in CDN, and then the content, let it be stored in Azure blob storage. That's the right way of designing the application, and if we do it, this application is going to run faster, or the application is going to respond faster to the users.
And with that, we have come to the end of this video on Microsoft Azure full course. I hope it was informative and interesting. If you have any questions about the topics covered in this video, please ask away in the comment section below. Our team will help you solve your queries. Thanks for watching, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.